All right. So why this workshop, and why sort of these two people with very different backgrounds who are organizing this workshop? So Frederick and I actually noticed that there are some kind of like concepts that are a bit sort of like some concepts that sort of like shared between the disciplines. And we met at a sort of online research group on qualitative methods, and we were both sort of saying, hey, I work on sound. So we ended up actually having a few Microsoft Teams calls and sort of like discussing sound. And then we kind of discovered that even though we have these different backgrounds and very kind of different approaches to sound, we really could have like interesting discussions. And I remember that Frederick was talking about sort of like, yeah, how we perceive sound, saying sort of like people look for voices in the sounds around them, you know, just in the same way as we look for faces and we sort of like see faces in the sky and everywhere. So in this sense, I think this is kind of like a nice way of describing this, that in a way there's some perhaps anthropomorphizing or some sort of like humanizing element when robots make sounds, at least sort of like interaction that's going on. So we kind of discussed different takes on the common works, also on sound, sort of like what different kinds of sounds are there. We've of course read sort of like similar works, so we're familiar kind of like to discuss these. And I think many of the things that Frederick described as important to a sound designer are things that I also recognized from human studies. For example, we discussed sort of like breathing sounds, how they can be used to make an inanimate object feel alive, and how they're also really important in human interaction and can sort of like even have a communicative function. Think when somebody is sort of doing these like strong in-breaths. Yeah, so that was really nice.
And then when we noticed that there are like a bunch of broader concepts that are important to the both of us, like the concept of dialogue or rhythm, or the concept of building and releasing tensions, are important to the both of us, but for very different reasons. Like I would say rhythm is important for a musical gesture, and then Hannah would say rhythm is important for the communication between two humans. So there are these really interesting common threads across very different disciplines from which each of us could very much benefit. And then we were wondering, what other perspectives are there? Could we look at our projects from somebody else's view and discover something that we didn't see before? What is communicated through sound that we haven't considered so far? And there is such a wide range of sound in HRI, from motor hum to vocalizations, bleeps and bloops, music, and there are so many disciplines involved, like design, conversation analysis, linguistics, music, engineering, psychology. So the purpose of this workshop is to bring all of that together as much as possible and ask, what do robots currently communicate through sound? And what could robots communicate through sound? And hopefully you will leave this workshop today with new answers to both of these questions. Scheduling. So we have broadly structured the workshop across 3 themes, looking into the ideation, the creation, and the evaluation of sound in human-robot interaction. Now, obviously, there's a lot of overlap between those, and many of the presentations today will talk about several of these themes, but we see them as pieces of a puzzle that all need to be considered to create a clear, bigger picture. Hence, we highlight them here, and they are broadly reflected in the keynote presentations. Before we begin, some housekeeping. Please keep your video off and your microphone muted, and type your questions into the chat. We have 3 coffee breaks, which are 20 minutes each, and during these breaks, we have a room open on GatherTown, which is a 2D video chat environment, which makes it possible to mingle, even though we're all currently sitting in front of our desks. It's fun, so give it a try. We'll share the link when it's time. And we will end the workshop with an open discussion, and that's already it. So handing over to Hannah.
Just a second, trying to navigate the screen and handling the people who are still entering the call. Yeah, so we're actually ready to start, and I think the comment about muting the video is mostly about during the videos, so that the sort of channel is not so full, but of course, you're very welcome to open your video during the discussion. We'll start with our first keynote, which is also a bit representing sort of like our theme of ideation. And I'm very happy to introduce Dr. Guy Hoffman, who is an assistant professor and Mills Family Faculty Fellow in the Sibley School of Mechanical and Aerospace Engineering at Cornell University. Prior to that, he was an assistant professor at IDC Herzliya and co-director of the IDC Media Innovation Lab. Guy Hoffman holds a PhD from MIT in the field of human-robot interaction and a Master of Science in Computer Science from Tel Aviv University. He also studied animation at Parsons School of Design in New York City, and he heads the Human-Robot Collaboration and Companionship Group, studying the algorithms, interaction schema, and designs enabling close interactions between people and personal robots in the workplace and the home. Among others, Hoffman developed the world's first human-robot joint theater performance and the first real-time improvising human-robot jazz duet. So that you can see already why he's here and joining us today. His research papers won several top academic awards, including Best Paper Awards at HRI and other robotics conferences. And we're very happy and would like to congratulate you also to your Best Paper Award, which you won yesterday. And I think with that, we'll just hand over to you to already prepare. A few words why we thought it's cool to have you is really because your kind of work shows how sound can be used for humans and robots to collaborate in meaningful ways. And you really did this sort of like joint aspect. So it's not just about sort of producing some beeps or bleeps when people kind of enter the room, but it's really sort of about complex turn taking. You've worked a lot on music, this sort of like back and forth between humans and robots in the jazz improvisation. And this is also one of these aspects where we thought this is kind of cool. You bring both sort of the collaboration and kind of jointness together with very interesting sound and animation design. So welcome everybody, Dr. Guy Hoffman.
Thanks. So I think now I can share my screen. I'm happy to see people's videos, and I'm happy to try having people's videos on. If we get some network errors or problems, let me know and we'll change that, but it'll feel more like other people here. Hi, everybody. Happy to see you. Some of you I know. I'm happy to see you again. And my reference, does anybody recognize the reference here in the back? It will relate to my last point at the end of my talk, but this background here, anyone? Twin Peaks. It's Twin Peaks.
Yes, Red Room. I gotta say,
the Red Room at Twin Peaks. David Lynch's production. David Lynch is one of my favorite artists and filmmakers. One of the things that he's maybe not as well known for, but really as importantly influential, is he does all of the sound design for his movies and for his TV series, and he's kind of like usually writes, directs, and does the sound design. And so if you are if you haven't yet watched any of his masterpieces, if you watch any of them soon, you should really look at the sound design. That it's a very important part of his art. I will talk about some older projects that Hannah mentioned, and thank you so much for the introduction. This was the work that was done around the idea of jazz improvisation. I will then talk about the follow-up project that happened out of this. So the first part is playing music with robots, and then out of that came this follow-up project that had more to do with playing music out of robots, sort of music that comes from robots, and then sort of play music alongside robots. And I want to talk about some thoughts that arose. If I'm disciplined, which I'm usually not, we'll have some time at the end to discuss a new question that I've thought of in the last few weeks. That's really interesting to me, and I would love to hear your feedback on. So hopefully we'll have some time to think and not just listen. So first, I want to talk about this project that's now, it's already over 10 years old. So it's a younger version of me here. And this is my work that I did with improvising with Shimon the robot, which you see here. This work was done under the auspices of Gil Weinberg, and in close collaboration with him. I was a postdoc in Gil's lab, and when he was the director of I think still is director of the Georgia Tech Center for Music Technology, which was my first encounter with music technology, really. I was a purely robotics person with some personal music interest and background, but like I went to do this postdoc, which was completely out of my comfort zone in musical robots. And I was stuck for several weeks and months with no idea what I'm supposed to do. And then I did what I always do when I don't have any ideas, is I promise something, and I signed up for a performance 6 weeks later. And the performance was published and my name was on the lineup, and there was no choice but actually get to work, this is the trick. If you're ever stuck, just put your name on some very publicized event, and I promise you'll start, filtering out the important questions from the tangential questions very quickly. The world of improvisation, I was very interested in joint activities, as Hannah was saying. And the world of robot improvisation was with Gil Weinberg sort of pioneered, and then we see a previous robot of his here was very much structured around this call and response, which is very typical of a lot of human-robot interaction. I was really interested in joint action. So the question I posed to myself at this point was, what is necessary for a robot and a human to play together at the same time, and not in response to each other, but sort of play simultaneously. There are some sort of interesting, what I want to do in this, what I also want to do is in talk, I want to go into a little bit of the details that I usually don't talk about when I talk about this work, hopefully of interest to people in the HRI community. So the robot that I met at the lab when I came there was this robot. It was a robot made out of 4 arms that could move very rapidly on a linear actuator back and forth. And we had some motor control code, and the robots were actuated by, the robot plays the marimba, which is this wooden xylophone. They were actuated by these rotational solenoids, which are really cool motors, actually. They're solenoids. If you have ever used solenoids, they have 2 states. They can either be on or off. So the solenoids are either all the way pushing one way or the other way. And in this case, it's a rotational solenoid. So it's either, so it's basically a spring in there, like in a watch, and it's either expands or contracts. And that was all you could do. You could select power this on or off. But I really wanted to have this sort of musical, the first question I asked myself is, how do I get more musical timbre and dynamic range out of these motors? Because you can't just play full on, hammering the machine. I mean, it's good for a robot, but it's not good for the audience. So one of the projects that I was really sort of proud of there, I never talked much about it since then, was the robot was learning how, kind of like motor babbling that infants do, was learning how its body worked. I put a microphone under the marimba, and I had the robot just turn the solenoids on and off very quickly, and try to learn a dynamic model of how the mouths work without having any it wasn't a real true to life model, but it was sort of like a learned model based on trial and error of the robot, with depending on how high the mallet was and how fast it was moving, and slowly was building up this repertoire of knowing its own sort of dynamic range, which strangely reminds me of when I was a teenager. I once was I was trying to kill a bee on a window, and I broke the window. I think I was 12 or something, and it was yeah, I didn't actually know I could do that. I was just trying to. So this is what the robot was doing, and using this model then later, it could actually control the mallets, even though, so imagine these mallets can only be full on down or full on up. But here's an example, or I might have not shared the sound. I'm going to share again with sound, because sound is important here. So I was able to have a much more fine-grained control over its power of play. Another bonus points if you recognize the tune. So this is an example of using these. So it was sort of like doing its own PWM to try to just barely touch the keys to get the sort of sound. Anybody recognize the tune? I'm going to do like a film like there's like a parallel talk here about giants in cinema. No, anyone? True Romance. It's a theme from True Romance. It's a Quentin Tarantino wrote and Tom Scott directed. It's worth watching. I'm going to skip this part, but this was basically a similar idea to sort of have like simulated springs that could manage. So one of the problems is that this is a very powerful motor. The horizontal motor was very powerful. It actually could get up to 2G acceleration and 3 meters per second velocity. It was an industrial robotic base, and many times over we've kind of just crashed these arms together. We did some like. Rob Amy, who designed this robot, did something kind of irresponsible and put 4 arms on the same rail, and they all basically could like go fully and crash into each other with 4G acceleration if they wanted to. So another sort of like motor control thing that happened here was I wanted these arms to move very fast, because before this they only did this like single nodes. But I said, well, if you have to move fast, you have to have some safety system in this. So I had this whole like virtual spring, simulated spring system going on where they would attract and propel at any point. Only one arm would actually be moving. The others were they were controlled, but they were controlled in like a zero torque mode where they would be pushed away from the moving arm by these virtual springs. And this enabled us to get, so this is all part of getting the robot to actually be virtuoso in some sense. So this is, one was the dynamic range. The second one, how can we make the robot move really fast without crashing itself? And here's sort of a demo of that. So to do this, the robot sort of at every moment, one of the arms was pushing the other arms out of the way to make room for it. But it happened fast enough so that the robots could sort of like play these types of things. All right, the third problem that I was trying to solve was to do this like call and response interaction, where I would play something at a certain beat, and then I wanted the robot to just keep playing at my beat. So the idea was that there was this phrase in the part that I was preparing for this show, and it went like da 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 da. And I wanted the robot to sort of, it had like 5 notes to learn what tempo I'm playing in, and then it had to like hit the next chords together with me. And I wanted it to just be seamless. And it's kind of like a simple trick, but it was very effective because it basically just categorized the tempo from my intro, and then we would hit 3 notes together, and all I had to do was play in like a normal tempo. I could choose any tempo, and the robot seemed to be very attuned to me and still, hitting the notes precisely. So you can see this idea of like 5 notes to learn the tempo, and then 3 notes to respond with me. So again, this is another one of those, like, just it's almost like a trick because it's not very hard to detect the tempo from 5 notes, but in a sense it seems like I can play however fast I want, and the robot is always on beat with me for these like final response chords. The fourth idea that kind of came out of these 6 weeks of stress was this idea of opportunism as a way to create seamless joint interaction. And opportunism, the idea that sort of went into this was this idea of wave interference. And the way that this works is that there's different things that I would do as a player that the robot would pick up on. So one of them could be like a beat. So here you can see like a beat, the left to right is time. and the lines are, can you see the lines? Are the lines visible? The lines are like the beat, so it's like da-dum, 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 da-dum. That's the beat you can see here. That's what I'm playing, and so the robot is doing some classification, picking up on the beat. And then the robot also has the overall tempo that I'm in. So it'll try to figure out whether, like, what my BPM is overall, and the BPM will drive the robot's movement. So my idea here was that the robot would be dancing around its instrument, kind of just listening and dancing, and then also picking up my beat, and then also picking up my chord. And all of these are very simple classification tasks. And then the whole improvisation the robot does is it's trying to find the interference between these. So as it's moving, so again, if this is time, as it's sort of like dancing back and forth in this waveform, and the waveform is going to change because sometimes it's going to move faster. It's going to sort of like move to my playing, and then it's listening to my rhythm. And then it also knows the chord I'm in. And so whenever it happens to be in a place where the rhythm and its position and my chord are matching, it just plays that note. That's all it does. But this again is a way, like the thing I was trying to solve was how can the robot seem responsive to me, but also be on beat and not have to wait for me all the time. So it's like always thinking, always doing, and just taking opportunity when it arrives and instantly responding to that opportunity, which I think has a lot to do with how people improvise. I mean, improvisation is not really, it's just like, it's this place between planning and acting. And the planning is in a way, just like, in my mind, the robot is just in the groove of what I'm doing and opportunistically contributing something. And so as I'm changing my tempo, the opportunities change, and the melody the robot plays, the red ones are the melodies the robot is playing. And as the chord changes, it also changes. As my rhythm changes, it also changes. And it always seems to be just up to just doing the right thing. And so again, let me show you what it looks like on video. So this is just the arm pattern it's doing. It's doing 4 of these. You saw just one in the graph. As I'm changing my rhythms, this is just for demo, it's changing the arm pattern. And here I'm just giving it one chord. I just changed the rhythm, same chord. It's doing a different thing. As I'm changing the chord and not changing the rhythm, all together, that's what it looks like. Again, I can't play, but you get the idea. So and better players just get better playing out of the robot because the robot is just picking up on all these elements and just integrating them in this idea. I'm going to skip this one because it's a very similar idea, just more math and not necessary. So let's show you some other examples. Okay, so I want to talk about the next project a little bit, and this was, as you can see here, the robot also has a head, and the head was part of the design that we did for this robot. And the head, to me, was very important because I could see what the beat tracking that the robot was doing. I could see whether it's off, or whether it's off by double or by half, and it's sort of like a very useful communicative tool to have this head bobbing. But what happened once we performed with this robot is that people didn't care at all about all my clever musical ideas, and were just really fascinated by the fact that the head was bobbing, and they were like, the head is bobbing, it's amazing. It's like the robot is just so into the music, and this robot is so human because it really digs the music. And we had a whole like Stephen Colbert piece about this, where he was saying that this robot doesn't just improvise, it also digs music, it likes music. And like, no, it's just like, for me, it was like a debugging tool almost, it's like this thing. And so as a joke, and here's my second tip for when you're out of ideas, take your like bar jokes to the next level and make them. I was telling Gil Weinberg, I said, what if we make a robot that doesn't play music at all, it just listens to music? and it just bobs its head to music, and maybe people would love that, and it's just so much easier. And he's like, yeah, funny, and haha. And then the next thing we did is like we started designing this. So this was like an early version of this, was basically Shimon's head in, you know, pocket format. Then we started going back to sketching a little bit different, you know, morphologies for it, and eventually it became this robot that has several names. We never agreed on what to call it. I call it the robot Travis. Gil calls him Shimi. This robot is basically just listening to music on your phone and bobbing its head. But what I thought was interesting here was something that will tie back into my sort of final question I want to pose to you, is that something, let me show you this, what this looks like briefly, but I want to discuss it a little bit more in depth. So again, the idea is you plug in your phone, you choose a song, the robot plays the song and enjoys the song. So here, plugging in response. That's unrelated. So I thought the interesting thing here is that there was a lot of disagreement about where the robot's eyes are. And I like to play with robot morphology, so I intentionally did not say that these were eyes, but some people thought that these speakers were eyes. Then I obviously would, you know, retort and say, obviously the speakers is the mouth because they're speakers. And then people would say, no, the speakers are the ears. And there was like a little bit of like, I don't know, like some irony here to just try to design in a way that you couldn't really map it onto human morphology. I actually like the fact that some people thought these like two little screw holes are the eyes, like right in the middle, which makes the robot suddenly look completely different. But what I think is more interesting is so the robot is playing the music, but also listening to it. And this whole, and in terms of, if you want to call this some sort of like provocative morphology, it's like, what is going on here? Is the robot playing the music in its own head? Is the robot you know, speaking through its ears, but reacting to it? And I intentionally want to have this a little bit vague in the design. The second thing that came out of this was this idea of, we did a study, because back in HRI, a lot of times you have a design idea that you can't get it published, and you had a study and then you publish it and you're angry and the reviewers are angry and nobody's happy. Although now the design world in HRI is changing, and we can, you know, 10 years later, we could have actually published this without a study, but then you had to do a study. So I did a study, and the study was, do people enjoy the song more if the robot moves to the song as it's playing it? But this brought up this whole point of what happens if the robot reacts to something, and you notice the robot reacting to something, and does it change how you perceive the thing? And this became a paper called Robotic Experience Companionship, together with Shira Baumann and Kinanva Nuno, which I think asked a very important question that I still don't see discussed much in HRI, which is, can a robot change your opinion about something by the way that it seems to think about something? And we call this like experience companionship, and we tested it with music. We did find sort of like a marginally, like a significant, or I like yesterday's discussion, unremarkably significant finding, where people did enjoy the song more when the robot was moving to it in its beat. We tried the same with the laugh track on the robot. The robot sort of laughing to it, and we didn't find a similar effect. We did find that people liked the robot more when it was enjoying whatever you were enjoying, which is a different thing. But it kept this idea in my head about, should we just build robots as like a laugh track in some sense, as something that accompanies whatever you're doing, whatever you're seeing. And you might think about the peanut gallery in the Muppets, in the Muppet Show, if that's different, you know, and Mystery Science Theater 3000 or whatever it's called, where you have these characters reacting to what's happening. And this brings me a little bit closer to what I wanted to talk about as a concluding question. We're not quite there yet, but this is this idea of what are the robot's roles? What is the robot's role in our experience of entertainment? Is the robot the entertainment? Is the robot the messenger of entertainment? Is the robot a co-participant in the entertainment? We try to actually do this as a company. There was some effort around I think was it the 2010 World Cup, or where was the World Cup in Brazil? The soccer World Cup. Anyway, maybe
2014.
Yeah, 2014, to sort of like have, make robots for different teams, and you could buy a robot for the opposing team and be angry when the robot would be happy when the opposing team scores a goal. And this whole idea of just sharing experiences of the robot. I started a little bit later, so I have a few more minutes, right? Is that correct, or should I just end at 3:10 and bring us back on time?
You have a few more minutes, but if we want to leave space for questions, I think.
Okay, so let me just. I'm going to skip this project. I just want to say that we do have a new paper out. It just came out with Antonia Carter and Marianthi Papaalexandri, where we did some new investigation into improvisation, a little bit more theoretic, and we worked with musicians and robotics engineers to try to see how they think about improvisation differently. So I'm just plugging in this paper, just came out last month. There's some interesting ways in which we found that musicians and engineers think very differently about what improvisation is. And I want to sort of bring us to sort of like a point of thought. And this is back to cinema. This is the idea of diegetic versus non-diegetic sound. How many have heard of diegetic sound in cinema? So diegetic sound is defined, I think, officially as the sound that the characters on the screen would hear if the sound in the world of the cinema. So if you are, if we have a scene with somebody driving, the motor sound, the sound of the ocean, people talking, this is all diegetic sound. It's sound. Then you have the sound that's, somebody's walking up a hill and you hear this, like, this background music is usually called non-diegetic sound. It's background music or some like screeching or maybe a heartbeat that you hear. So this is overlays the often sound. There's like Mel Brooks has this sort of like funny take on this. I'll just play this for a few seconds.
One can never predict a heart attack.
Heart attack? Huh! Don't make me laugh.
Brophy, what are you saying?
If you
So we have
ask
the
me,
motor sound.
I think Dr. Ashley was a victim of
With the
foul
speech.
play.
And this would be a non-diegetic sound. But of course it's Mel Brooks, so he's playing with this idea. And I think this is an interesting metaphor for robots, and especially robots that play sounds. Does the robot hear the sound it's playing? Does the robot, is in the robot's world, does this sound exist? Or does the robot make a sound that only exists in the human world? If we connect robots to different media experiences like music or video, does the robot hear everything that's on TV? Does the robot hear the music that it's playing? And I think this question, this metaphor of diegetic versus non-diegetic sound for robotics is something I actually would like to pose to you, maybe for part of the workshop, to think about if this metaphor has any interesting mapping to robot sound, both inherently physical sound of robots like motors, but also sound that robots produce through speakers, and maybe that robots just channel from the cloud to the person. So I'll stop here, and I'll be happy to take any questions or hear your ideas about diegetic sound for robots.
Thank you very much. So you can raise your hand. You can also use the chat to ask your questions. I think there was one question in the chat about the head, but I think that got answered. Can you give us a quick thumbs up?
I didn't track the chat.
It was about whether the head of the robot of Shimon, I think, has any purpose other than looking nice.
Yeah. It was answered, like, it was right before Professor Hoffman was talking about the head of the robot.
I have an anecdote about this, though. I have a follow-up story. When I showed this at this media event once, this very famous news anchor came to talk to me, and he's like, "So the head is doing basically nothing, right? It's just moving to the sound, all the intelligence in the arms." And I told him, "Well, you know, you got to be careful, because one could say this about you in the news. All you're doing is just moving around to the news, and the real news is the thing." And he was like, took a few steps back and realized that nonverbal communication is actually an important part of content provision.
We have a question in the chat from Karl Müller. Music is often used in movies like leitmotifs. I wonder if you could use similar types of musical motifs to convey an emotion from the robot. Any thoughts? Or Tobias?
I like this idea. I think this is exactly this idea of the non-diegetic sound. So imagine like a robot talking, and suddenly the robot would play this like and then it would use this like musical, maybe even cliches to instead of facial expressions, or imagine a robot that doesn't have a face, and you can just use these dramatic sound bites to express emotions. I think that's a really clever idea. I also have a small follow-up. Story from there is we spent a lot of time trying to do, which I think Gil Weinberg students, I see Rich Savory here, were more successful at than we were later. And this was to try to really have the robot detect emotion in videos as the robot was watching these videos with us. And what we ended up finding is that the most predictive aspect of mood in these video clips was the accompanying musical key. It was a major or minor key. That was if the robot would just listen to that, it would be much better at predicting the emotion in the scene rather than facial recognition, etc. This might be a little bit of an aside, but.
Thank you. Very nice. Frederick, do you want to ask a question, or should I just read it out?
Yeah, sure. So you were talking about having to do user studies 10 years ago, and now there's a possibility that we can skip that part. Do you think there's value in conducting user studies to test for specific effects in these new robot designs, or would you skip if possible?
I think user studies are useful when you have a question you want to answer. I think making up a question for the user study is missing the point. So I think they're very useful if you have a question, and the user study could bring you closer to understanding this question. I feel like one of the problems is that a lot of times when you do synthetic research, like design research or AI or technology research, the contribution is really in the product of the synthetic research, on the thing you synthesize or the thing you created, whereas often the knowledge that you're trying to gain from the user study is just a confirmation of what you want to convince people of, which I don't think is the right use for an experimental study. Experimental study should answer a question you don't know the answer to. It's a little bit off topic here, but I love talking about experiments, so we can have a whole discussion on that.
Yeah, I think there's very different perspectives on that, of course, and I agree very much that it's kind of like difficult, of course, if you're just sort of like doing the evaluation to prove that your sound is working. We have more questions. My personal thought is that robots can take you to a different world with some background music or soundscape, e.g. beach sounds, and now teaching a kid about concepts at the beach by Angelica. I think it's not really a question.
It's a really good idea, though. Hi, Angelica. I saw her before, but
yeah. And then we have more questions. I think Christina has been raising her hand for a while. Would you like to pose your question?
Hi, yeah. Thank you for your talk. That was really entertaining and interesting. When you started to talk about detecting emotion just now, and I'm thinking about like, how might you use, like, could you have the robot near you, and if it senses that you're getting sad, or you're not feeling well, can it like turn on certain music to cheer you up, or like do certain movements to make you happier, or just sounds. And then like kind of in parallel to that, I often think about like the music that I'm listening to is kind of a soundtrack to my life. Like even, when a lot of people run to music, and, you're listening to Eye of the Tiger as you're like running up a hill, and it makes you go faster. And I think, I don't know, I'm thinking about how you might use that to like affect your mood and that kind of thing.
That's a really good point. It reminds me of William Gibson, who's a science fiction writer. He's sort of said to have said that one of the biggest revolution in technology was the Walkman, because it was the first time that you could bring a musical soundscape with you to a different place. And it was sort of like the beginning of the whole introspective way of us consuming media. And up until then, I try to sort of like tell people, I remember myself before the Walkman was invented. The sound was only the sound that was around you. I mean, this was all you had. You could never choose what you hear until the Walkman, unless you were at home. And so I think this idea of, carrying sound with you and the robot being a messenger of sound, rather than just a producer, I think is a really interesting idea. And we do this also when we talk. I mean, we want to make people fall asleep, we can sort of make the sound of waves, and it's not completely out of character for an agent to bring sounds into the space. So.
Well, and I think there's even literature on like when the radio started being installed into cars, like it changed how people like used their cars and thought about driving and that kind of thing. So anyway, thank you.
We have a very last question before we'll get to the participants' presentations. Ella is asking, could we argue that the sounds of the robot embodiment, I guess that's sort of like the sounds that come from the machine of the robot, would be the diegetic sound of the interaction? I think that's a clarification question, or also.
Yeah, I think that would definitely be the diegetic sound from the human's perspective, but I kind of want to think that the robot lives in its own world where it has other diegetic sound. And in my opinion, toying with the boundary of this is where it's interesting, where you can the robot might be living in a different, just like we saw in this comical clip before. The humor is in the fact that we're playing with this, and it's happened all the time. Tarantino also does this a lot, where you're hearing a soundtrack, and then at the beginning of Pulp Fiction, the opening credits end, and then the same song plays on the radio of what's his name, John Travolta and Samuel L. Jackson. They hear the song on the radio that you just heard in the cinema as the credits were playing. So this idea of breaking the boundaries is where I think we have some interesting opportunities.
Thank you so much. There's another question in the chat, but I think we unfortunately have to move on. It's also about the sort of animation, which we will get to also in Ben's keynote, I think. So we saved that. So for the first round of participant presentations, we're gonna share the videos one after each other. Thank you, Guy, very much. And we're gonna allow you to just post on the chat while the video is running or after they're running, and then we're gonna have a round of discussion together. So like we welcome the presenters of these videos to join us for the sort of like plenary discussion afterwards. We do that so that we can kind of like get more of a dialogue. We also asked you to make videos that are perhaps a bit more introducing sort of like your research in general. And I will now share the first video.
Hi, I'm Elias. I'm an artist and researcher from Augsburg, Bavaria in Germany. For the arts part of my life, I'm doing installations, sometimes media and audio related stuff, sometimes kinetic and often reflecting on systemic configurations, being part of larger contexts and experimenting with the perception of our surroundings. There is, for example, Performers Lucilia sericata, a live video installation where a colony of flies is living in a backlit frame, and I wrote a software tracking the flies, connecting them each other with a line. The lines are projected beside the frame containing the flies, so you see a very reduced representation of what's in between these animals, but giving you a whole new perspective on these. A quite new installation I did is Matter, which is a needle similar to a needle of a compass, but pointing always towards the center of our galaxy. The last one I'd like to show you is Monolith, a turntable-like device turning colors into control voltages for modular synths. This was also my bachelor thesis, and this connects most to my proposed PhD research project. In the research part of my life, I'm working together with Professor Andreas Muxel as research associate and PhD student at the Hybrid Things Lab of the University of Applied Sciences, Augsburg. There we are working together with design and media students on how we would like to shape technology. Most of the time it's about robots. And we are doing a lot of experimenting, prototyping, and physical computing, so I'm working a lot with laser cutters, 3D printers, electronic parts, cables, even more cables, tools, oscilloscopes, eyes. Hold on, eyes? Well, this is a really interesting discussion sparking here. Robots will never see, they will never have feelings, and they never will be alive. So I think there is a huge gap between what triggers us emotionally and what is a useful tool. And I really hope to contribute with my research to humane technology which respects us as humans with all our unpredictability and not seducing us with fake promises. For those who didn't read my submission, I proposed a PhD project in which we generate the audible presence of a robot by mapping the robot's internal parameters to sound generators in real time. Until then, I map musical parameters to human body movement. Gosh, how I miss the dance floors.
As I said, you're very welcome to post questions in the chat. I'm gonna just move on and share the next video.
Hello, my name is Iain McGregor, and I am the Programme Leader for the Sound Design degrees at Edinburgh Napier University in Scotland. I conduct research into the fields of sound design and listening, making use of our custom 28.4 channel surround sound auralization suite. My doctoral research focused on methods of comparing sound designers' expectations with listeners' experiences. This work has continued, encompassing a wide range of topics from sonification of exosolar planetary data through to XR dance, video games, as well as systems to support those on the autistic spectrum. My perspective on sound and human-robot interaction is to think of robots very much like high-functioning autistic children. There's an inherent need to understand the rules in order to interact naturally with humans. What annoys one person can make another uncomfortable, whilst a third may find the interaction endearing. I aim specifically to study the ways in which sound can be used to maximize the levels of comfort and to investigate auditory cues in both directions in order to make interactions as seamless and natural as possible. This initial work starts with naming, as names can allow users to indicate their expectations immediately, not only through the choice of nomenclature, but also the manner that they address the robot. This facilitates immediate customization and reflects contemporary human-human interaction, where the chosen address can indicate levels of intimacy as well as other factors such as levels of frustration or distraction. Long term, this can be combined with the monitoring of vocal cues to vary a robot's auditory output. A nervous patient being carried by a robot could have the sound of the motor emphasized to provide reassurance that there is sufficient strength, whereas for a more delicate task, a clicking sound could be introduced to confirm that a limit has been reached and the object being held will not be crushed. Sounds can be trialed with the strength and style of the response measured to create rules for future interactions. If a pet name or nickname is utilized instead of a more formal one, then more playful sounds akin to a companion could be utilized, whereas the curt address of robot may elicit a perfunctory confirmation sound accompanied by just enough sonification to indicate that the required task is being enacted. Initial studies will focus on establishing whether choosing a name for a robot could convey user expectations and how these might be translated into auditory preferences. Long term, I am very interested in real-time monitoring so that every sonic element seamlessly integrates into task or person-orientated human-robot interactions. I would be delighted to collaborate on any project that seeks to study how humans auditorily engage with robots in order to improve the experience for all involved. Thank you for listening.
Hey together, my name is Bastian Orthman and I have the pleasure to introduce to you our concept for displaying robots' actions and intentions via sound. This is the topic of my master thesis that I'm currently working on as part of my studies at KTH in Stockholm in interactive media technology. I did my Bachelor's of Arts in Audio Design in Berlin and have been working a lot with spatial audio and 360-degree video since. I'm very fortunate to be working on this current project together with my supervisor Ilaria Torre and Iolanda Leite, who have done a great job in introducing me to the field of robotics. In our work, we suggest a layer-based classification framework of robot characteristics to sonify robots' internal states. Everything creates sound. We produce it whether we want to or not. One might even say, only death has no sound. But if every entity emits sound, that also means that every sound has a meaning, right? Therefore, if we want to create entities to interact with, we also need to give a meaning to their sounds. I personally feel disoriented when I don't sense sound and stressed when it's omnipresent and too intense. But how should artificial entities sound like? Should sound be a byproduct of the mechanical movements? Or should it even be an aesthetic art piece that pleases us? Well, an important characteristic of sound is that it serves as a reliable information cue that requires low cognitive load and allows non-focused interaction. So I'd say, let's take advantage of acoustic information while creating a comfortable sound environment. To achieve that, we can use procedural audio, which provides flexibility and scalability while giving the option to feed non-audio related parameters into a system. For that, we need to have a stable system that deals with constant values and dynamic values that are independent from each other, but at the same time create a unique identifiable sound characteristic. Therefore, we need to understand which iconic features describe a robot's action, and so its intention, best. Our layer-based classification framework contains constant values, such as physical base, and dynamic values, such as main goals, internal states, and action. We are planning a workshop with experts in robotics to identify the features to be classified. The outcomes of the workshop will then be mapped to sound parameters such as wave type, ADR curves, distortion, reverberation, and so on. Our vision for sound in HRI is that it's a suitable medium for encoding information about unique situations, and that it's a complementary modality for conveying information and therefore might help to reduce the cognitive load for visual perception. We hope to create a scalable and flexible framework for displaying robots' actions and intentions. I want to thank you all for listening and watching, and I want to thank the organizers of the workshops for giving me the opportunity to present our ideas. Please feel free to contact us if you have any remarks or ideas for collaborations.
Hello everyone, my name is Gustavo Assunção and I will be presenting our proposal for an emotional regulation system based on sound manipulation. In terms of our perspective of sound in HRI, we address it as an information-rich modality from which we can determine, for example, user location, evaluate their degree of activity, extract personal information, and so on. All of this can be used to improve interaction and make it more adequate and enable an adaptive behavior towards the users. So here we propose the following regulation system. In terms of emotion, we consider a three-dimensional model of continuous score instead of discrete states, and based on that we can imagine how certain areas in the model can lead a person to more negative outcomes, For example, how sad states are likely to worsen the condition of a user with depression. And so the goal of the system is to assess if people are in these so-called danger emotional areas, and if so, guide them towards neutral or more positive areas. As you can see in the diagram, the loop is made up of 3 major models. The sound synthesizer is the module in charge of playing sound appropriate to the scenario at hand. As a first step, we consider here a data pool of tones varying in frequency, pitch, and so on, which are mapped to specific locations of our emotional model. The interpreter is meant to measure the emotional state of the user from their activations. This can use different modalities depending on the level of intrusiveness of the application, but most likely will be based on speech and facial samples. The classification model obtains information about the user's state from the interpreter and determines their location in the emotional model, and finally, based on reducing the user's distance to the closest emotional safe zone, an appropriate sound is chosen by the synthesizer. To strengthen the correlation between sound and emotional ratings, we're also devising an online survey based on this 2018 paper here on the bottom, which first proposed a correlation between emotion and sound. The idea is to continuously play a set of varying sounds to the volunteers, and after each sound is played, we ask the volunteers to place themselves on the emotional model using a user-friendly interface, in addition to also assessing their facial expressions. This is meant to help us better aggregate sound characteristics by emotional state and make the regulation system more robust. As previously stated, our main goals are to avoid dangerous situations caused by overly strong emotions in people, but mostly people can be negatively impacted by those emotions. Other objectives also include stress reduction and also bond development between users and robotic social companions. Applications are mainly focused on people who are more susceptible to be negatively impacted by strong emotion. Best examples are probably elderly people and children with social-emotional disorders, such as those within the autism spectrum. I hope the presentation was helpful, and thank you.
All right, we would like to ask the presenters of the videos to come on stage to join us, show your video, and join the discussion. So we have the first question in the chat, which is directed to Elias. Using a robot's internal parameters to feed a synthesis engine sounds like a fascinating sonification project. What are the benefits you expect from this?
Yeah, hello. I hope this is working. Can you hear me? Yeah, perfect. Thank you for the question. Yeah, what I didn't tell you in the video, it's about especially non-anthropomorph robots. So I try to, or we try to sonify the physical state of the machine, and the benefits from this are that everything what surrounds us, and most of the time we interact with physical artifacts, they have some inherent sound. And so my question is a little bit, so what would be if we could change those sounds, and how could we change the interaction with a machine? So I think I'm searching for more abstract sounds there, and I think it's not about pushing the human into a specific direction. And this is also an art-led PhD project. So I think it's also about a little bit going into some of the extreme directions, maybe also some disturbing demonstrations or experiments, or some really smooth things. So yeah, I hope that answered your question.
Yeah, there's also a follow-up question. Really interesting work. It seems like the classification of the robot's internal state would be a big hurdle, especially to extend to different robots. What kind of framework are you thinking of to do this? And this is a question from Brian.
Yeah, Brian, thank you for the question. This is definitely not about classification. This is So I showed this robotic arm. This is a Franca Amica Panda. And this machine is built for a direct human-robot interaction. So this machine is so subtle in its in detecting touches, and completely physically speaking, this is so subtle in detecting torques and forces on the machine, so that you can directly touch the machine, so you don't need any safety cages or something around this. And you can use these information to drive sound generators. So my plan is, for example, if the machine is just in an idle state standing before you, for example, and it's a 7-axis machine, pardon, just take the motor torques of these 7 axes, map them to an audio synthesizer, and and then it goes up to interaction, moving, maybe tasks. And then I think it's interesting to see, or this is also part of the project, how which values are relevant for mapping onto what parts of musical or sound anatomy in the end. So it's definitely not about classification. It's more about mapping the physical state to an audible presence.
Thank you. That's interesting. It would be interesting to see sort of like how that actually works, and whether you can kind of distinguish like the different states and what that would communicate. We will have like more questions to other presenters. So to Gustavo, what sounds do you have in mind to affect users' emotional state? It doesn't seem like an easy task. Humans are complex, and this is actually a question that I was also wondering about. Would you like to say?
Essentially, like bleeps and bloops, like Frederick said. The paper we based ourselves on mentioned a correlation between varying the sound features, and that would have different effects on people. And we intended to test that, right, with our online survey, and see like what is that exact correlation and how we could generate better samples to specify and induce specific states on people. But for example, if you want objective examples of how that will work, you can think of, for example, R2-D2 on Star Wars. You can pretty much know how the robot is feeling by just bleeps and bloops and beeps, what it is doing. So our base is that if we're able to reproduce that, maybe we could use sounds like that to induce certain emotional states on people.
Okay. Do you think it would be useful to involve sort of some of the sound designers here to design these sounds?
I mean, sure, if you have any ideas on how to do that, if you have some proposals.
Yeah, I mean, just as an open question. There's another question from Hibbert asking, have you guys already implemented that system? Can you give more details on how the sound synthesizer works? Very briefly, please, because we don't have very much time.
We have not implemented the system yet. We're still on the online survey portion, but it's going. We have some modules prepared, like the facial and speech emotion recognition part.
Thank you. I think we have a question for Bastian. What are the benefits of a generative sound generation system? Why not just use the most effective sound cues over and over again?
Thank you for that question. Well, the idea is to have a flexible system that can be used with a lot of different robots in a lot of different scenarios, basically. And we really want to start from the basis and try to get there for, like the generative system would help us to be universally applicable in all different kinds of situations. And yeah, that's basically where we want to go to, that it's that we create something that people who don't have sound expertise can use. They feed in parameters and then it would work, basically.
You also mentioned these experts. Have you kind of like, could you elaborate like what kind of backgrounds you want to involve there, since we're also here in this interdisciplinary workshop?
So in this workshop right now that we have planned, it's about people who are robot design, like HRI designers, and some with media background and some out of robotics. And this is basically intended to find out the features that describe the robot's actions or that occur during a robot's action, so that we then can work with that and map them on audio parameters. So we want to, this is focused for people on who actually have worked a lot with robots before, but not so much in the sound domain.
Thank you for clarifying. Brian also clarifies that he actually addressed his question to you. It seems like the classification of the robot's internal state would be a big hurdle, especially to extend to different robots.
Yeah, so there again, basically what I'm interested in is in finding out what is the mind of a robot in a way. So that is why I want to go to the internal states. And it's definitely a big hurdle, but I think there's not really work in it done yet. And so it will be really cool, I think, if we can go from the internal states, because that is what we humans do, right? Like we have an internal state, we have an emotion or something, and based on that we produce sound. And so I think it would be really cool if robots could do the same.
Interesting. Thank you for your answer. We have a question to Iain. I hope I pronounced your name correctly. What are the sound properties that you would adjust to fit a person's preference? Genre, sound, aesthetics, any thoughts?
Pretty much everything. The very first thing would be gender, because some people see robots as companions, some see them as servants. So they can get very offended if a robot automatically starts speaking as a woman or a man. So the gender is the first thing. Then there's the relative age. We can look at how popular those ages, those names are in particular age groups, and that'll give a style of the language that's being used and the expectation of how chatty or restrained they are. Then as you go through and people adopt, but also having different names means that somebody who's more nervous with a robot might just call it robot. Somebody who's more comfortable with a robot might call it Fred. And within the same household that's using them. Then there's how often it makes sounds and and the type of sounds that it makes, whether it's more encouraging, whether it's more matter of fact. And again, just like our parents and our partners and even our pets, we say our name in a slightly different manner. If we want to be more perfunctory and we just want them to do something, then we'll use one form of the nomenclature. Whereas if we want them to be more engaging, more reassuring, give us feedback about what they're doing, we might use a more softer version of the name. But it's only the starting point, so that as soon as we interact with the robot, we have an initial set of settings, and then those evolve over time. And if we continue to call the robot by name, then we've got a more personal connection with it. Whereas if we can continue to refer to it as a device or drop the name and just ask to do tasks, then we know that the auditory elements need to back off, and it's no longer a companion, it's back to being a servant. So it's really just a starting point so that we can explore all aspects of the auditory generation. And can I just tell a couple of stories first of all, for the Twin Peaks. David Lynch is such a fan of sound design that his best friend Alan Splett, who was his original sound designer, he actually has a few of Alan's ashes buried under his desk, so he feels like he's guided by Alan when he's working. And the positive and negative aspects of R2 are actually partly George Lucas, as well with Ben Burt, and that's the baby sounds that they produce together that have been mixed in. So it's actually the two of their personalities that are representing R2D2, and you can see the positive and negative aspects all the way through in terms of sounds by the relationship to the even order, odd order, and disharmonics that they use throughout the films. And that's how you can tell whether a lightsaber is a good lightsaber or a bad lightsaber, or the weapons that are being fired are good or bad. So that's been explored way back in 1977. Anyway, sorry for going on.
No, thanks a lot. I think it's very interesting. I also like to think about what you said, sort of like in different cultures, how do different names sound in different cultures and so on. Unfortunately, we have to cut the discussion here, but we have a break until the full hour. So a few minutes to take a cup of coffee or tea, some water, and we will post the link to GatherTown here in the chat. You're very welcome to test it. You can just click on it and you go through it through the browser. I think you can pick an avatar and then you should be good to go. It's a mingling platform where you can just move with the arrow keys on your keyboard. And when you get close to somebody, you end up in a video call. I think you can switch off your camera if you don't want to be seen, but you can just talk just as you prefer. You can also stand in groups. There's some pianos to play music and some games hidden in the, or not actually hidden, but sort of like placed in the room. So you're very welcome to explore that, but keep in mind to be back at the full hour so that we can start on time with the next keynote. All right, I think we're going all back to the Zoom call to continue, just so you know.
Okay, we're slowly coming back. I'm going to share my screen.
We hope you enjoyed the break and perhaps got to play some music.
It's true, there was a whole piano jam session, which I thought was excellent.
Did you set this up specifically with the pianos in the space, or?
Yeah, I put the pianos there after I discovered them, had them fun by myself.
Have them brought in.
Got
a whole moving company to
carry it in.
Yeah, exactly. Hannah, do you know how many people we have in now? 49. Okay, that's good enough. Ben, are you here?
I am here. Am I audible?
That's fantastic. Yes, you are. I'm just going to introduce you, and then you start your talk.
Sure.
So our keynote to start the second block, which is about creation, will be done by Ben Gabalden. Ben is an interaction sound designer at Facebook. And prior to that, he was the lead audio designer of robot manufacturer Anki, where he designed the sonic language of robots Cosmo and Vector, which I'm sure you're all familiar with. He collaborated with a team of sound designers, character artists, animators, game designers, and roboticists to develop and implement the unique personalities of these robots. And he did so by applying tools and experience gained in interactive audio design from the context of video games. I'm super excited to have Ben here today because his work on Cosmo and Vector is, in my opinion, the most refined, conceptually rich, and meticulous design of any physical robot that's currently on the market. It's like it's taken directly out of a Pixar movie, and that level of quality and polish, and more generally the film sound design and interactive audio perspective, I believe has a lot to offer to this community. So I'm very excited for his talk, and without much further ado, Ben Gabalden.
All right, thank you. That was an amazing intro. I really appreciate that. I thought that I was going to need to start from the beginning and explain who I am and why I'm here, but I'll do it anyhow. So yes, I was fortunate to arrive at Anki before they had developed Cosmo and Vector. So I had, borrowing from my history in games, well, we'll get to that part. What I'm here to talk about, obviously, is the sound design, but really from the creative perspective of how to start from ground zero working in robotics and try to figure out how to design audio that makes them really feel alive and relatable. And so I got the opportunity to step in as Cosmo was being developed, and then later moved on to Vector. And there was actually some other robots being designed down the pipe. But you know, I have to say, I'm extremely excited to be here. It's amazing to hear the same conversations, you know, even just this a little bit earlier, conversations that we've had, problems we've had to work through. It's fantastic that there's a whole community thinking about this. So thank you for having me. So some of the things I wanted to cover, there is a whole lot that went into obviously both robots. But what I do kind of want to walk through the story arc today is going to be, you know, who I am and how I became an advocate for audio and robotics. What it was like to arrive at Anki and see Cosmo and start from the absolute beginning with really no foundation or direction. And then the process of identifying what came to be the voice of Cosmo. And then applying the learnings of character audio to a non-linear experience. So, you know, obviously robotics are out and I'm borrowing from games, open world, meaning there's really no linear story. There's no narrative. So you have to make this experience that makes sense in any context. And then towards the end, it really started making sense to me and becoming an objective to distinguish between interactive audio, and immersive audio as it applies to robotics. So I'm also going to try to leave quite a bit of time for Q&A because there's a lot to cover and you might have some more specific questions. So I'll just give the broad strokes and we'll get started. So beginning, who am I? My history is actually in designing sound effects for video games. So I've worked on a lot of different video games. I was doing games for about 12 years. A lot of sound design across all types: creatures, weapons, combat, user interfaces, successes, all kinds of things. And I really sort of got my core experience in designing things that are representative of a moment in a game. But also I got into voice acting, which was not really a choice of mine. I kind of got forced into it, but it became an important experience for how to get performances out of actors to create like a really clear and emotive narrative. But also importantly, in history of working in games is developing audio systems that are dynamic and interactive. So, you know, it's common for maybe a footstep system. You can identify the surfaces, how fast it's moving, you know, the weight of the person, and build this really dynamic system that becomes believable. And that becomes really important in creating robotic sounds that feel natural. So all of that being said, it's really about creating a dynamic, nonlinear experience. And that's true in games. It's old news for games, and applying that into new technologies was just an unexpected surprise. So to be honest, when I arrived at Anki, it was a contract. I was excited to work on their previous project, Overdrive, which was combat racing cars, which is a little bit more familiar with my game history. And when I got there, it sounds like people are a little bit more familiar with Cosmo than I was anticipating. But you know, Cosmo has 2 treads, has this lift that moves up and down, has an LED screen with a front-facing camera, which a lot of people confuse for a mouth. But also, there's just that little speaker on top of his head. So his head's a little bit mobile, his lift, and he can drive around. And that's really the core of what Cosmo is. So in the very beginning, I arrived and they had just a few copies of this 3D printed body about the size of a fist, and really nothing more than that. And years of really amazing, just a small army of engineers built, electrical engineers, AI, hardware. They built this amazing little body. They could move, it could track faces. It was a really complex little robot, and that was an achievement in itself. But there wasn't really anything more than that, and they needed sound. So I came in, day one is, here's the product, now figure out why this will be interesting and how. So borrowing from my experience in games, I just immediately thought, okay, we're gonna create a matrix of what this robot is going to emote. How can it communicate? So I thought, great, we'll have happy, we'll have angry, we'll have sad, curious, excited. So we have 5 categories of emotions that this robot can potentially express. And then I thought, you know, I'm going to be advantageous, and we're going to go further. We're going to have long category, medium, and short of each emotion. So happy, for example, could have long, happy, emotive sound, medium, and short. And now we're sort of creating this modular audio system that can be applied to anything the robot does. And that was great, except when you create these banks of generic sounds, they might be interesting, but they don't necessarily connect with what the robot truly, like, more deeply is trying to express. So I found that, you know, I understand that the sound was happy, but if you play it out of context, you know, if somebody can't see the robot's face, it's a lost sound. So the goal became clear to me that we need to really, really dial in emotive clarity so that you can experience a sound and understand what its intention is, what the emotion is, without necessarily having the context of seeing the face or understanding what caused the sound if you're not watching. So we really, really had to start thinking about sounds that can fit the character and be connecting with people. So again, like arriving there, the conversations, we got to find voice. We got to find the voice. What's Cosmo's voice? This is his main way of communicating. So this needs to be the thing that draws people in and connects with them. So it has to make sense to people right away. So of course, this is where I could talk forever about this part, trying to figure out what does a robot sound like was a long process. It was months of really focused, specific effort. And I started with just basic synthesis. We got, a contact mic and started moving things around the desk. We just, tried different synthesizers and all kinds of crazy stuff. I hired an actor and just put him in a room. It's like, be a robot and then we'll just see if it sounds good. Can you just perform like a robot? And it just kept iterating and iterating and iterating. And I'm sort of proud of some of the robot sounds that we came up with. They were really complex and cool. Maybe they belong in a movie or a show, but again, they just didn't express clearly what Cosmo would be feeling. They sounded interesting, but interesting wasn't what's going to get people to connect with the robot. So at the end of the process, I think by the time we started reaching maybe version 25 or 26, we started moving away from synthesis and started using a little bit more vocal performances as the source audio. So I found that if you take just a human recording of nonverbal performances and run them through just a basic synthesis or processing chain to get them to sound a little bit more robotic, and then pitching up just a little bit for accommodating the size of the robot, so it really kind of fit the body, that human element, even if it's saturated with other effects, that is the thing that was drawing people's attention and they connected with it. So another huge benefit for us on Cosmo specifically, starting with the human voice, is it also opened the door wide open for iteration. So I just had a microphone in the audio room and I could just start speaking gibberish. And another, benefit of having done a lot of voice acting or voice actor directing was being able to vocalize and practice different phonetical structures and seeing how they sounded through the vocal processing. I had an infinite audio source engine, as it were. So dialing it a little bit closer to human is what really started connecting with people, and having the opportunity to iterate and try different vocal patterns is what started really sort of cracking the code on what made Cosmo feel real. And that was a huge success. I was really excited, relieved to finally have the voice of Cosmo, and people responded really well to it. And it was a lot of fun just leaving them on the table in conference rooms. But the thing is, he just kept making the same sounds, and they were Cosmo, but I started trying to step back and think a little bit more thoroughly about how people communicate. And yes, you speak to people, but we rely on so many other cues, audio and visually. You have facial recognition, facial expressions. That's an entirely independent form of communication that often, couples with voice, but same with body language, intonation, nonverbal vocal responses like exhaustion, for example, or anger. We have all of these different dimensions of communicating. Sometimes they work together and sometimes they can be independent. So looking at Cosmo, he also had animations for his eyes, and those were really detailed. They're bouncing around his lift and his head movements and spinning around if his treads are moving. These are all different ways that Cosmo could demonstrate he's sad, angry, and utilizing those avenues as ways so that he's not constantly vocalizing, but he's still communicating, became a way to have a little bit more of a dynamic character. So I got to use that original matrix that I was proud of for the voice and had happy, angry, sad, excited, curious. And instead of applying that to voice, we just created hundreds of little digital telemetry sounds to fit those categories. So that if Cosmo makes a facial expression, we don't have to rely on the voice. We can have a sad sounding transition of his eye shape. And then similarly, we borrowed that same matrix and created hundreds of emotively shaped servo sounds. So little synthetic servos that were mixed small enough that they were indistinguishable from the actual sounds and motors on the body, so that if Cosmo lifts his lift up, you're going to hear the natural sounds of the robot. But if we play just enough of a happy or an excited lift to sort of supplement his emotive experience, it's just all of these subtle subconscious experiences. He's constantly able to output audio communication without having to verbalize it. So now that we have this audio system and we have all these components to play with in this massive modular approach to the sound for Cosmo, we have to start applying that to what open world means. So again, I like to use the example of setting Cosmo down on a conference table and having a room full of people. You might be in a conversation. If Cosmo's rolled to the other side of the table, you lost your context on what Cosmo might be thinking or feeling. And in this process of trying to come up with a sound for Cosmo, and I'm sure this is true of all robots, we have a massive history in society of robots that we've grown up with or we've experienced and we understand. And I started trying to, I had to fight against what people's expectations of Cosmo were going to be. You have a lot of famous robots that they just speak. So that's already unfair. We're not going to have a robot that can just clearly communicate. And R2-D2 is another really good example of amazing sound design, extremely expressive. And you get the gist of what R2-D2 is expressing, but you also always have a context where there's another character. So if R2 just lets out a long, series of sounds, you've got a contextual person right there, just like basically parrot back what he just said, but in spoken word. So it's this unfair advantage of them getting to interpret what R2 means directly to the audience. But then also, again, with TV and film, WALL-E's another really amazing example of incredibly expressive robots, but you also have a linear story. You have a narrative, you have context, you have, situational understanding, where if there's a sad sound or a scared sound, you understand why they're sad or scared. If you're having a conversation and Cosmo just reacted to the clip of the table, you need to be able to hear that without looking at him, seeing his face, and understand that he just got scared. That's what gives the robots their independence. So now that we have these great sounds, how do we create this, what I would say is non-contextual relationship building, so that they are very clearly behaving, feeling, and you understand that when you don't necessarily see them, you're not interacting with them. So really thinking about our audio design is not being, make this moment cool that you're directly interfacing with the robot, but allow that robot to feel expressive wherever he's at, whether you're interacting with him or not, and have that sort of relationship and that understanding of their feelings. So again, I'm getting further and further outside of my roots in game design and really thinking about character. And we were a little late to the game doing this with Cosmo, but with Vector, we went into it really building a foundation and a core understanding of the character. So it could be whatever fiction you come up with, but understanding that core character so that you can build all of the sound and behavior and animation around that really gave us an understanding, having a bedrock of something to work towards. So character development, even if it's not expressed of the robot, having just a creative understanding of what your goal is going to be is extremely important. And this is a huge one that I wish I got to take more advantage of. We did a little bit more on Vector, but these are incredibly complex objects, so there's all this information that they're making robotic decisions with. And this is, inputs that are being used to drive motors, to drive behaviors, to drive, other interactions to make the robot side seem cool. But that's still data that can be used to drive other systems. So, the time of day, we actually took, with Vector, I finally got to put tread sounds in there by taking the motor data. If the wheels are driving forward, backwards, velocity, and it drives a procedural audio system so that there's a volume and pitch curve that is directly tied to the physical motors of the robot. And it was mentioned earlier about music. For Cosmo, that's one of those things that I really had a good time and unexpected time with, is using the behaviors, the stage of a mini game that you're playing. All of that data drives a fully interactive score that comes out of your phone. So if you have your phone up on the table and you're on round 2 of a mini game, the music actually escalates and it transitions with him. So he does have his own fully interactive score at all times. So yeah, again, data, there's so much cool stuff in there. And then going further, now that we have the sound and we're understanding the open world, and as Cosmo really started to sort of take shape and we started to really understand who Cosmo was, I started really finding the importance of understanding the difference between something that's interactive and something that's immersive. And by that, I mean something interactive, you can interact with a robot and get an expected response. You can do things and sort of like trigger a call and response. And it's cool. It's a really cool, modern, interesting toy. But what can we do to be so believable that you don't even recognize as a toy, but it's like magic. And that's really became the new goal, is like making really cool sounds was the start, making it seem really, contextually agnostic, great. But now really make people believe that that robot is alive. And that's where I think all the little details came into play. So having synthetic motors play in conjunction with the physical motors to sort of wrap this fiction into all these little moments, I personally find it gratifying if people don't even know there's a full interactive servo system, because it really should just support your belief that it's real. So, hundreds of these little sounds are going on and you might not notice it. And I think it might even be better that you don't, because it just fills in the gaps of people's understanding. So that subconscious experience is a huge component to making them actually have their own independence and realism. And I absolutely can't stand up here and talk about how great the sound is and how the sound really sold the experience. I feel really good about what we did, but we had a very close collaboration with the animation team. So the same level of detail that we were thinking and putting into the sound design, they were doing with animation and held themselves to a really high standard too. So when their eyes move, I can hear if there's distortion in the file, and they can tell if the eyes don't squish just enough. Like the level of detail they're putting into it and our collaboration and understanding the character and what our common goal was is how it came together. So I have to give a huge shout out to the animation team and their level of detail. And it's, also for Anki for putting faith in having a creative team to sort of wrap a fiction and a character around already amazing technology. And I started getting a clear idea of what I feel like it's like to have these in the home. So now that you have an immersive character, how do we make it so that they seamlessly live with us? And that opens up a whole lot of questions, like, Vector especially. Vector was an entirely independent robot. Cosmo had to be tethered to your phone, so he had a little bit of limited mobility, but Vector, you could set down on the table and just leave him there. And another, great examples I think we just started to tap into using data is, the ambient noise level in a room impacted how loud the sound came out of Vector. So we were using the ambient volume of a room to drive the relative audio system. And also there's a variable that we called stimulation. So how recently he's seen a face, how recently he's seen a cliff edge. All of these were driving a variable that he really could just live off on the table. And if you're not interacting with him, his audio system begins to get quieter and it plays sounds less frequently, so that he's not just chirping in the background. So developing systems that the robots can continue to live with you without always being this performative object became a whole new sort of goal for us. And as we spent a few years and I started really understanding Cosmo and starting to understand Vector better, and we started beginning to work on another much larger robot, I really enjoyed the successes we had with engaging people. And I felt like in the end, seeing people be so connected with the robots and getting letters from parents whose children are now finally interacting with socially when they wouldn't with other people, I felt like true empathy and connection with these robots is the highest form of interaction that we could achieve. So had a great time working on all the sounds, and I feel really good about it, and I could talk about it forever. But I think the most gratifying takeaway that we had was the ability to make people believe that they're real. And another earlier point, I'm looking at technology around the house now, and how do we, how would I guess the open question would be, would you want to feel empathy with your devices at home? I saw earlier in one of the slides, the googly eyes, a little drawer. We have a Roomba, and I put 2 googly eyes on it because I wanted personality out of my Roomba. And when it bumps against the wall, like you can track, maybe it bumped into the wall 5 times within 30 seconds. And what if it played a sound that it was frustrated? How do you build, would you want to have technology in your home with character? And also, one of the robots we were working on, another point that I want to bring up was presenting this larger robot and really having them demonstrate how cool they could drive around the room, and object detection and avoidance, door detection, all this really cool technology. But what sold the moment, what really sort of broke down the barrier between humans was this robot would look at whoever was talking, and then there was a presentation on the TV, and as the presenter and the visitors would look at the TV, the robot would also use directional audio facing and watch with them. And that was more important than demonstrating how cool the pathfinding was. That is the one moment that they're just like, this is something amazing. So I think building that trust and that believability was just the highest form of success. So thanks. That's sort of the short version. There's obviously tons and tons of stuff that went into this, a lot that I'm still trying to remember. So I'm more than happy to talk about this anytime. I've got my email here. I very rarely get to hear people this enthusiastic about sound for robots. So feel free to reach out anytime.
Excellent. Ben, thank you so much. We've had a bunch of questions coming up in the chat, and I'm just going to start with the first one. This comes from Guy, who asks, have you ever considered to have a series of Cosmo robots who all look the same but sound differently?
That's actually what came up with Vector. Vector was originally what we were calling Cosmo 2. And the very early stages, it's the same form factor, but they just have much better technology. Like I said, Cosmo, you have to be tethered to a phone. Vector, they embedded the CPU on the robot, so he was fully independent. There's 2 drop sensors, 4 microphones, voice command activation, all of that, like much higher technology. But I mean, it's an entirely separate presentation I get into on Vector, because we needed this absolutely similar looking robot be an entirely different product. It needed to appeal to an older audience. It was more of like a home companion than like a child's toy, right? So Vector, we didn't get to rely on the human audio source. We had to design something absolutely from the ground up. And whereas Cosmo's kind of like, his character's more like a toddler. Vector, we put a lot of effort into making like a little critter in your home. It's just a robotic critter friend, and all of the sounds are purely synthetic. So in terms of like developing another family, given time, we probably would have.
There's a question from Bastian, which says, do you see benefits of using samples versus generative audio?
Almost all of, actually all of both robots were samples. So the entire system for both Cosmo and Vector, we were fortunate we got to use the WISE engine that was embedded in both of them. But all of the voices are individually edited, named, imported, every like screen sound. Procedural audio is something I had another sound designer on my team that was really trying to get that to work. And I think given time also we could have found it, but procedural audio just failed to get the emotional clarity, and that was the most necessary goal.
Great. A question from Brian. So it sounds like there was a lot of work and success in incorporating the motor sound of the servos, but if you had the choice, would you prefer a robot that is completely silent?
Oh yeah. Yeah, the motors were a challenge for a lot of things, especially once Vector came around, and one of his features was going to be dancing to music, but if he moves, his servo sounds overwhelm the speaker, so he can't hear anything. So we broke a lot of our character fiction by having him have to sit still. If possible, an absolutely silent robot would be amazing. And then the one of robots towards the end was a large one, and it was almost completely silent. And we did get to start building a procedural driving system. But another interesting challenge is when you have a larger robot that could run over a dog or scare the children, like you have to be a little bit more delicate with how they communicate. And having sound that sort of expresses its intention clearly and calmly was a whole new goal.
Great. Moving on, I'm just trying to get through a bunch of questions because people are very curious. So there's 2 questions around user studies. One is around, have you compared the effect of the sound design on non-musical people versus musical people? And the other one is, did you do any user-centered study?
We did not do any music-centric studies. So we didn't, I don't think there was any questions surrounding what what sort of user feedback we were getting. So a lot of our decision making that happened, especially on Cosmo, was just relying on our own internal quality test. It was, if the animation lead and the character director, if they didn't believe it, it's not going out. And same, you know, I felt like I had the same sort of quality control responsibilities, that if we believed it, it would go out. And towards the end with Vector, we started refining a system, and the audio room was actually directly across the hall from our user research studies. And unfortunately, we didn't quite build a system agile enough that we would get user feedback before we did something. So it was often like an after the fact responding to information. And again, like, it was sometimes user research, if it disagreed with our creative decisions internally would prevail.
Great. Ben, thank you so much. I've got a couple more questions which I'm going to save for later for the discussion. And we're now going to move on to a bunch of presentations for today, for the second block.
Good.
So on the screen here, those are the people that will play their presentations now, and then afterwards we'll continue with a Q&A. Hannah, whenever you're ready.
Hello. In this short video presentation, we will briefly illustrate the results of Sonao project so far. This is us, the research team, and we are from KTH in Sweden. The Sonao project wants to establish new methods based on sonification of expressive movements for achieving a robust interaction between users and humanoid robots. We designed sound models by implementing effective mappings between stylized body movements and sound parameters that will enable a robot to express high-level body motion qualities through sound. The first study in the project focused on mechanical sounds inherent to the movement of a now robot based on movements translated from a mime actor. Perceptual experiment revealed that these sounds did not carry much emotional information compared to video stimuli of expressive gestures. However, some sounds did communicate certain emotion. Overall, the mechanical sounds appear to communicate arousal more effectively than valence. In a follow-up study, blended sonification was used to enhance and further clarify the emotional expression of these sounds. The results revealed that blended sonification successfully contributed to enhancing the emotional message for sound models specifically designed to convey frustration and joy. To further explore the sound models suitable for the purpose of the project, we are using focal sketching as a prototyping tool. The same professional mime from previous study was asked to produce focal sketches on video recordings of his own movements. The focal sketches were then transcribed by two composers and later re-synthesized. The results were then compared to investigate how the audible outcome changes for different transcriptions and synthesis routines. With the same goal to explore the sound design strategy, we also looked into the robots of science fiction films. Excerpts from 5 films were annotated and analyzed based on their sonic spectra. That is all for this presentation. The project is still ongoing and we plan to continue with several experiments. Visit our websites to read more about the project. Thank you for watching.
Hi, I'm Ella, and on behalf of my co-authors, Dr. Keith Strong and Professor Vanessa Evers, I would like to tell you more about the exploratory framework that we discussed in our paper, Sound and Sensibility, to Beep or Not to Beep, as part of the Challenge project from the Human Media Interaction Department of the University of Twente, funded by SIDN and ClickNL. If you have had the chance to read our short paper, you have seen this framework before. In this framework, we show the different facets that build up to deciding whether the robot should use sounds or speech during the interaction. In this presentation, I would like to explain this framework using 2 example scenarios. First, let's start with a fairly simple scenario. Let's say we want to use a now to playfully help children learn about the different shapes in a primary school classroom. We are talking about young children here, since they might not be able to use speech yet, and they might also not understand it, using beeps might be more effective. The interaction should be playful, so the children learn by playing. This means that the robot should use some social skills, and sounds can be very effective to convey these social messages, as studies have shown. This playful interaction might also result in mixed initiative in the dialogue, meaning that both parties can start it. As said before, children might not be great at conveying initiative through speech, and we argue that the robot should match the child's behavior. We also argue that because the domain of the interaction is constrained to playing with shapes, sound should be enough to convey the robot's intentions. Furthermore, since the robot has many other modalities at its disposal, the robot shouldn't have to use complex utterances. And since other children will be busy in the classroom, this might create quite some noise in the background, which also argues for sounds instead of speech. So in this scenario, we argue that the robot should use sound in the interaction. Beep beep. Now, let's move on to a more complex example. What if we want to place Tiago as a bartender in a crowded bar? It could come across all kinds of adults, with no specific target group in mind, except that they like to hang out in a bar. This doesn't really help us decide whether to use sound or speech. However, since bartending is a very social job with a lot of small talk and customer service, sound could be perfect to convey these social skills. But when we look at the initiative, speech might be the better choice, because adults are accustomed to using speech to convey their intent, so maybe the robot should match this. This is further supported by the domain, which is not really closed, since the small talk could be about anything, but the main goal of the interaction will be the ordering and serving of drinks. But Tiago could use its other modalities to convey these more complex messages, so then maybe sounds would be enough. And there would be a lot of noise in a bar, so using complex utterances might not be the best option. So, what does this mean? We argue that it might be an option to let the robot talk, but also use beeps from time to time when there's a lot of noise, for example. But what do you think? We would like to hear your thoughts about this more complex scenario. Maybe some factors have more weight and might therefore tip the scales. Thank you for listening, and please feel free to contact me for further discussion.
Hello, everyone. My name is Sudhir Shenoy. You can call me Sid. I'm a PhD student in the computer engineering program at the University of Virginia. I am a human-robot interaction researcher focusing on socially assistive robots and child-robot interaction. My perspective on sound in HRI is that sound is one of the underappreciated modes of interaction that we can exploit in human-robot interactions. So in this project, in this paper that we submitted to this workshop, we have focused on a scenario where a humanoid robot is talking to a child in a medical environment where the child is stressed, is going to experience pain of a medical procedure, and we want the robot to be there in the medical procedure room to talk to the child, distract the child with sounds, music, or even try to sing a song with the child to distract them from the pain. So the goal of that study is we are going to use exploit multimodal ways of getting that interaction, reaction from the child, so as to keep them distracted throughout the process. But we are also, we understand that because it's in a medical environment, there are a lot of background noises that the child are normally hearing in that space, and already building up that nervousness or anxiety or even fear entering that room. So we want the robot to be there to try to sort of drown out those other noises so that the child can focus on the robot and do sounds that are more distractive or even fascinating to the child. Benefits we expect out of this workshop is feedback from other researchers who have worked in similar child-robot interaction projects or scenarios. And we haven't collected real-world data yet because of our access to hospitals right now is limited. So we hope we can get some feedback from people who have done these sort of in-person studies with children before and get their perspective on how they handle sound in HRI. So looking forward to sharing my work with you. Please take a look at my paper submitted on the workshop's website. And if you have any question, please reach out to me at sid@virginia.edu. Thank you.
Hi everyone, I'm Akanksha Saran, a PhD student at the University of Texas at Austin. I'll be presenting ongoing work with my collaborators on a case for leveraging human prosody for robot learning. While many of you at this workshop might be thinking about sound from the perspective of robots, we want to present our perspectives of leveraging human sound for HRI. Specifically, we're interested in the setting where humans teach tasks to robots via demonstrations. This robot learning setting is known as learning from demonstration or imitation learning. This is a natural and low effort setting in which naive robot users can show examples to robots of how tasks should be performed. We propose that human audio can additionally be leveraged along with demonstrations to improve the learning performance of such algorithms. Audio is a rich communication channel widely used by humans when they demonstrate or teach tasks to one another. Spoken words can provide clarifications about the intent of a human demonstrator, as shown in these examples. Often, how something is said can be equally important to what is said. Audio can also contain prosodic cues such as careful enunciations, slow speaking rate, increased pitch and loudness, which can further reveal how well the demonstration is being performed. To analyze if audio is informative for robot learning, we conducted a user study on Amazon Mechanical Turk for a simulated domain of a robotaxi, which needs to pick up passengers while avoiding obstacles. We record the user's demonstrations and their audio in this setting. We find that human demonstrators convey information about successful and erroneous parts of a demonstration in this setting. Here's an example.
Right, good. Yeah, that's good. Let's go back this way. Down. No, not. God damn it. Oh, that sucks.
We also conducted a user study with the situated Sawyer robot. We also find evidence of demonstration errors and successes being correlated with prosodic features like pitch in this setting.
Oops. If it drops, let's pick it up.
We propose that human prosody is a useful cue often ignored in robot learning algorithms and can be leveraged to improve the sample complexity of different approaches. Thanks for your attention towards our perspective on human audio for HRI. We look forward to further discussions of the workshop.
All right. Thank you so much, everyone. We have one more presentation.
Well, welcome everyone to our video and our robot hotel, where we think the way a robot speaks at one time may feel completely inappropriate in another scenario. We think a robot should adapt the way it speaks based on different conditions. I'm Angelica Lim from the Rosie Lab at SFU in Canada, and I'm here with Akihiro Matsufuji from Tokyo Metropolitan University. My background is originally in music robots, but then I went into vocal dynamics. So we like to think about how a robot should adapt its voice, and this can depend on social factors like actual physical distance between a human and the robot, or the social distance in terms of status, on the emotion of the human, it should adapt the way it speaks, even on things like the cognitive differences, like the level of the language ability between the human and the robot. Akihiro is going to talk a little bit more about environment.
Thank you, Dr. Lim. This is Akihiro Matsufuji from Tokyo Metropolitan University. I would like to explain the study of the effect of a shared auditory soundscape on the perceived ideal speech rate of an artificial agent. Background ambient sounds are a common source to affect the arousal of both the human and an agent. As for speech rate, higher arousal was expressed with increased speech rate. From these backgrounds, we aim to compare the relationship between the preference of speech rate in various soundscapes. We collected the impression of the artificial agent and the preference of their speech rate in the combination of text-to-speech samples with 3 kinds of speech rate and 4 soundscapes. Participants were recruited from Amazon's Mechanical Turk. The result shows appropriateness of rate of speech affected the social perception of agent. As a result, if the participants felt the speech rate was inappropriate, the rating scores decreased in meta-attribute competent and warmth. On the other hand, in the meta-attribute discomfort, only if the agent spoke too fast, the rating score increased. This result shows the impression of the appropriateness of speech rate with soundscapes. Contrary to our expectation, default speech rate was preferred by raters in both soundscapes. However, there is an interesting result from this project. Over 30% of participants preferring fast speech rate in noisy office environment. So we need to consider not only speech rate, but also other factors for finding appropriate speech voice.
All right, thank you very much. We're going into the question, and I just want to start. If you have questions, just type them down in the chat, and I'm going to start with Bastian's comment on Adrian's work. It's not really a question, but I'd love to hear Adrian's thoughts on that, which is, Bastian says, I like that you started from vocal sketching, research through design. Adrian, can you speak to that a little bit?
Yeah, thank you. Thank you for the comment, Bastian. So I think what we want is something that is more like trying to involve the users as well in the process, and doing sketches, like sketches with your pen and pencil. It's, I think, one of the easier part to get, you know, what you want from your audience. And vocal sketching, I think, is one way to get the ideas from the users to how they want the robot should sound like. So that was our angle with that approach.
Right, thank you. A question from Pauline to Angelica and Akihiro. For online experiments using and assessing sounds, how do you deal with the speaker volume on the end of the participants?
Thank you very much for your questions. We do not control the speaker volume of the participants. So we ask participants only, please listen to this sound on a quiet environment.
All right, thank you. Just want to read out a comment by Brian saying he's not one of the speakers here, but they've made their own little version of the Harvard Music Lab online studies method, which they include in their studies. And there's a link to that. So anybody who's interested in trying to control that element of an online study, check out the link. I'll do it for sure. Then we have a question for Akanksha, which is, how did you collect the participants' data related to sound through Mechanical Turk?
Yeah, thanks for the question. Yeah, so we have a Heroku app, and we actually route users to a different web page when they sign up for the study, and we can actually use the microphone from their computer. And we ask them specifically to use a specific browser and sort of within the constraints that we could handle during the pandemic.
All right, thank you. Another question by Hannah, also to you, Akanksha. Did you ask people to vocalize?
Yeah, that's a good question. So for the Mechanical Turk study, we just tell them that the agent can actually listen to you, and you should use audio in whatever way you feel will help the agent to learn better. So there was no explicit instruction to talk, but they knew that their voice was being recorded, and so that kind of primed them. For the Sawyer studies, for the robot, we had actually two conditions, one where we explicitly asked people to talk, and the other one where we just told them the same thing, that the robot can listen to you, but we didn't explicitly say that they have to talk. So yeah, we're kind of exploring these two questions. And obviously we've seen with our Sawyer work that if we ask people to talk, they maybe talk like 50% more than in the other condition where you don't say anything to them, because yeah, some people just prefer to not talk.
Right. Thank you. I've got a question for Ella saying, how would you transition from beeps to speech? How and when could this be mixed?
Yeah, great question. So of course, I think it would be more natural to use only speech or only sound, because then it's easier to interact with and you know what to expect as a user. But sometimes maybe, for instance, when you have the Tiago in the bar example, and there might be a lot of noise, and you might as a robot not need to use speech to convey really content words and really complex intents, for instance, then sounds might be a better solution, just to have a quick understanding of the robot versus the user, and they can quickly communicate without actually these content words, this content of the intent being in the way by the noise.
All right, thank you. I've got a question for Zoot here, which is, do you think robot sound is specifically suited for doing these distractions in pain management that you're working with, or would any sort of distraction do?
My answer is we're doing non-robot sounds for that, especially because the environment where we plan on testing this, there are other medical devices in the room which are already giving the beeping and the whirring sounds. So we don't want another machine, another robot giving out similar sounds. So that's why we want the robot to give out other distractive sounds. For example, one of them being like mimicking a monkey or an elephant and making those sorts of sound, or even using sort of like a cartoonish character sounds to keep the children distracted.
Yeah. All right. Thank you very much. Okay, I've got a last question going out to anyone who'd like to answer it. For all speakers, with your HRI sound studies, how often are you telling participants that the focus is on robot sounds versus a non-disclosure or partial disclosure experimental design? Who wants to talk to that a little bit?
I can share a bit from our part. So most of our studies are about perceptual studies. So we do at the beginning tell them that the participants will be exposed to videos with visuals and audio, or sometimes just audio, and they have to put some ratings or to answer some questions. So it is very obvious that we'll tell them this is about the perceptual ratings or perceptual experiment on the robot. That's from us.
So like a little vague. Like you're saying it, but you're not fully saying that, right? Okay. Anybody else?
In our study, we already, like, because it's a multimodal interaction, like we are looking at the facial expressions and their voice and background noise and other such modalities. So we want to yes, we will be disclosing that early on in the informed consent. And because our target population here is children, so get the informed consent from the parents. So there's no problem with us saying that ahead of time.
All right, I've got another question for Ella, which is, are you thinking of other contexts apart from, oh, you just answered that. Very well. Then I'd like to pose a question on the topic from before. Do you think that telling people that we're about to test how they feel about sounds is going to change what they tell you afterwards? If we warn people that we use sounds to change their emotions or opinion on something, and then we ask them if it worked, will that influence their answers?
Depends on the wording, I think. So if you say that, if the experiment says that you might have to have some ratings on the emotions, then perhaps there's some effect on that. I'm not really sure, but with experiments with sound, especially the ones that being done online, it's obvious that it's about sound, because we, at least for us, we ask the participants to check on their speakers. We have some sample sounds playing at the beginning. So without saying anything, I think they know that it's about sound. I don't know about everyone else.
Okay, another two questions for the round. One is recommendations for any database related to sounds, and the other one is, do you guys conduct quantitatively or qualitatively?
There's a great BBC library with sounds that I can say about that.
Shruti, sorry,
I was just going to say, I briefly looked at the audio set data set that Google Research has released for different kinds of human and object interaction sounds. So that's something that it's a very large data set, and they also have some models that they've trained with that, which are publicly available.
Interesting. Could you post the link to that in the chat?
Sure, yeah.
Maybe this is what us can do as a sound in HRI community, to provide like data sets that can be used by other people who are in HRI but not in the sounds, to have better sounds in overall HRI.
I think that's a great idea.
Yeah.
Okay, thank you very much, everyone. So we're going to go into another coffee break, and this one's going to be 15 minutes. So at 1/4 whichever hour you're in right now, we'll continue with the final block of the workshop. And now see you either here or in Gather Town or nowhere in 15 minutes.
Yeah, you're welcome to continue like using the chat or as we've done before, play some piano or other instruments and get it done.
Mm-hmm. All right, I hope everybody can hear me well. My fuse blew and I'm just restarted everything, but that should do it. Welcome back, everyone. Thanks for still being here. Our keynote to start this final block, evaluation, would have been by Dylan Moore, who is an associate at McKinsey & Company, and prior to that was a PhD candidate at Stanford. But for reasons beyond his control, he could not join us today. We invited Dylan because he co-authored 2 papers in 2017, which pretty much laid the foundation of consequential sound in HRI research. So consequential sound is the motor sound of a robot. And he was looking into how those sounds influence how robots are perceived. And that research created a lot of attention in the HRI community. On the one hand, it made people aware, like even who were not working with sound at all, that every physical human-robot interaction has sound, which is always present, and that sound impacts how people perceive robots. And then on the other hand, it inspired a lot of subsequent research, like including my own, and like some of the projects that are being presented here today. So Dylan asked us to express his sincere regrets to you for not being able to join and to share his contact details with you all. So if you would like to chat about his or your own research with him, then please do get in touch. But for now, we're going to go straight to the presentations, the final 5, which are on the screen right now. Hannah, whenever you're ready.
Hi, my name is Amy Allen, and I'm a PhD researcher at Monash University, Melbourne, Australia, working with Professors Tom Drummond and Dana Kulik. Currently, I'm researching consequential sounds produced by robots and techniques to augment these to improve human perception of the robots. Sound has the potential to delight or to really annoy people. How pleasantly a sound is perceived varies between people and also between contexts. A particular sound will be perceived entirely differently if you're having a drink with friends versus trying to concentrate on a project you're working on. Robots are increasingly being deployed into human-occupied spaces. I believe that sound is a key component as to whether we, as humans, can get along with robots. And so it's extremely important to consider sounds that robots should make for human-robot interactions. Importantly, we also need to consider sounds produced by robots co-inhabiting our environments, which we may not be directly interacting with. Arguably, robotic sounds are even more important in this context, as human tolerance of sound is decreased if we aren't involved in the activity generating that sound. Sound techniques used to generate positive human-robot co-location soundscapes will form a great baseline for useful sound for other HRI purposes. A key component impacting these baseline sounds are consequential sounds. Consequential sounds are the sounds a robot is forced to make due to their actuators as they operate, such as the whirring or grinding sounds you might get from a DC motor. Research has shown that the contrast between these abrupt consequential sounds and the lack of sounds when a robot is stationary is typically perceived unpleasantly. The suddenness and loudness with which consequential sounds typically start, stop, and change is disruptive to people. But even the quiet or lacking sounds can cause a problem, with people reporting feeling snuck up on by robots or electric cars that are too quiet. As embodied agents, robots really need a soundscape which includes a sense of proxemic presence, in addition to minimizing the disruptive consequential sounds. I am currently researching techniques to augment consequential sounds, which will allow a variety of robots to augment their own unique consequential sounds, creating a new, positively perceived soundscape. We aim to develop algorithms that will allow robots to learn how to adapt these sound augmentations to meet the needs of a specific context and the individuals in that shared space. We will be conducting HRI studies within naturalistic lab settings to verify the robotic soundscapes generated. Please read our paper and feel free to reach out to me if you'd like to discuss this topic further. Hi.
Hello, I'm Brian Zhang, and I'll be talking about the work that I and my co-authors, Professors Chris Sanchez and Naomi Fitter, have submitted here and elsewhere on sound and human-robot interaction. My research in robot sound started because robots are just so noisy. Most robots today don't have a lot of attention paid to how they sound, and as a result, robots often become a source of noise, annoying, distracting, and even painful. While working with robots, I've spent a lot of time wishing that robots sounded better. But sounding better is no small feat. Should robots just be quiet? Play music? Work in product sound design has shown that preferable qualities of sound can vary. Assuming that people prefer quiet products, for instance, doesn't hold up if users associate loudness with qualities such as power for vacuums and motorcycles. Thus, our overall goal is to identify the key changes we can make to robot sound that will improve human-robot interactions. As a first step, we manipulated loudness and pitch, which, along with timbre, are the main psychoacoustic attributes of sound. We conducted a pilot study to test manipulations in loudness and pitch with 4 different robot arm sounds: original, attenuated, silent, and downshifted. Results from the Robotic Social Attribute Scale showed differences in perceived competence and discomfort among the conditions. Based on these results, we formed new, more specific hypotheses to test. One, that reducing the loudness will lead to perceptions of lower discomfort and higher competence. And 2, that lowering the pitch will lead to perceptions of higher discomfort. This leads into one of our main goals. We want to be confident in our findings, and that means reproducing them. To do so, we performed 4 follow-up studies on the UR5E robot arm. We also performed similar manipulations on 2 different motions to see whether findings were consistent for the robot or were motion specific. Another main goal for us is generalizability. We want to know which findings we can apply across robots as a whole and which ones are domain specific. One approach from robots in the media and in human-robot interaction research has been to use music as an inspiration for intentional robot sound. We created musical sound profiles for 5 robots of different domains and form factors and conducted online studies to see which effects were consistent across all studies. Last, but not least, we think collaborations are key. I'd like to thank Professor Jason Fick from the Oregon State University Music Department, musician, comedian, writer, and filmmaker Nick Stargu, and Professor Chris Sanchez from the Oregon State University Psychology Department for their assistance. I'm also looking forward to continued and future collaborations, both from within and beyond the HRI community. Thanks for your time. I'd be happy to answer any questions.
Hello, I am Pauline Chevalier, and I am going to present my work on motor sounds and their impact in socially assistive robotics. I am French from Paris. I did my studies in electronic engineering and robotics, followed by a PhD in robotics. After a postdoc in the University of Twente, I am currently at the Italian Institute of Technology. All my research work has been done in the area of socially assistive robotics for children with autistic spectrum disorder. I am especially interested about how sensory sensitivity can affect social interaction with robots. Robots are a complex source of sensory information, and the motor sounds can affect the interaction with the user. The impact of motor sounds is important in socially assistive robotics, especially for autism spectrum disorder. Indeed, they show hypersensitivity to auditory stimuli. However, we cannot delete motor sounds. So, how to deal with it? Can we determine groups of children diagnosed with autistic spectrum disorder that beneficiate or that are overwhelmed by motor sounds? The approach we propose here is to evaluate the children's sensory sensitivity by means of questionnaires filled by the children's therapist or parents, and to link it to the robot's motor events in the interaction. This way, we hope to learn about the children's sensory sensitivity and adapt the robot behavior to them. In our research, we use this method to link sensory sensitivity, and more specifically auditory sensitivity, to motor events from the robot Cosmo. We looked at the robot's animation of happiness and sadness, which were used as a reward in the interaction in the course of urgent attention training. The reward animation were simple custom animation with a smile or a frowning face appearing on the LED display of Cosmo, and simple body movement. Other than the motor sounds, the animation did not present auditory stimuli. The therapist was able to activate this animation to reinforce correct or incorrect answers, and at the end of the 12 trials as a reward to have participated. The therapist could skip the robot's animation if they considered that it did not provide reinforcement but a distraction. The results suggested that children that have a high sensitivity in hearing might benefit from fewer animation from the robot, or in this context, less noise from the robot's motors during the training phase, not to trigger their sensitivity. As we cannot cancel motor noises, we can use this information to design robots less challenging for the children. For example, children with higher auditory sensitivity could be presented to a quieter robot that would present fewer or shorter animations, causing less motor sounds. The use of sounds to attract children with lower sensory sensitivity should be investigated as future work. Thank you for your attention.
Hello everyone, I am Omar El Dardir, a PhD student at the University of Genoa and Istituto Italiano di Tecnologia. Today, I'm going to present our work entitled Auditory Perception for Interactive Robots, a cognitive framework to include motor commands and working memory in the process of auditory sound localization. Auditory perception plays an important role in our day-to-day lives. There are a huge amount of useful information that can be extracted from audio. Localizing the sound source is one of the essential skills in auditory perception. It is also a challenging task for the robots, especially for those that use binaural hearing, because of many reasons such as noise. In HRI, localizing the sound source can be extremely useful. For example, in industrial working environment, the robot can respond to different sound signals from both the environment and the human operator. Our first goal is to enhance the localization abilities in robots in terms of accuracy and time. Secondly, and inspired from the evidence that humans perform head movement to improve their auditory perception, we also want to empower the robots with this skill. Finally, we want to explore how different motor strategies can improve the robotic auditory localization skills. This is our proposed model. It consists of 4 main blocks: sensory input, audio localization, memory, and motor actions. I want to highlight here that the audio localization is a Bayesian model. It computes the interrular time difference from a binaural audio input. Also, the audio power is used as a trigger to detect the existing of the sound signal. Finally, the working memory is used to hold both the state of the sound signal and the state of the action. We tested our model with 2 different motor strategies, 10 degrees toward the right and 10 degrees toward the left from the 0 initial position of the head. The first result was encouraging. It showed that our model works. It also showed an improvement in the accuracy when the robot moves its head toward the direction of the sound signal. This drives us to the further exploration, which can include the speed of the movement, the initial and final position for the head. Me and my supervisors want to thank you for your attention. I am looking forward for your questions.
Hi, my name is Lucas Grass, and I'm the CTO of Reverb Robotics. And today I'm going to be presenting on an end-to-end platform for human-robot speech interaction that we are developing. So I thought I'd start off this talk with a quote from Donald Norman that says that it's the duty of machines and those who design them to understand people. It is not our duty to understand the arbitrary, meaningless dictates of machines. And at Reverb Robotics, it's our view that speech is a natural mode of interaction that's going to enable machines to understand people, rather than people having to go the other way and understand the arbitrary design of a machine. And what's really made this possible is machine learning technology. It's enabled this accurate speech recognition, and it's really going to allow robots to understand sound in general, but also what people are saying. Speech that's directed to the robot and just speech in the environment. That being said, human-robot interaction faces unique challenges during these speech interactions. So robots produce lots of noise through their motors and actuators and fans, and they might also be operating in noisy environments. So there are definitely technical challenges to overcome before this becomes a reality. So at Reverb Robotics, we're developing an end-to-end platform that's going to solve a lot of these technical problems. So we're developing a small board that is based around the Raspberry Pi compute module, and it's around 7 centimeters by 4 centimeters. So it has a pretty small footprint, and it connects to digital MEMS microphones. So this is going to solve a lot of the issues from electrical noise that the robot might produce. And so these microphones can be placed anywhere on the robot and then connected through a cable to our board. And on the software side of things, we're going to support speech recognition, natural language understanding, and text-to-speech. So the board's going to come preloaded with all this software, as well as clients for communicating over a robot operating system and YARP, and also directly using C++ or Python. So this design is really going to allow roboticists to get up and running with speech interactions right out of the box without having to solve a lot of these technical problems. But I thought I would take the last little bit of this presentation to open up to some questions for the audience, because I definitely want to hear from you all at the workshop. And we're curious about some of your use cases. At Reverb Robotics, we've been floating the idea of having a board that has a built-in GPU. So we're curious if you guys want to run custom neural networks on the board. And we're also curious about how important other sound interactions are. So just having a robot that's aware of sound in general, and maybe able to do sound localization and other features such as that. So I'm definitely interested to hear a lot of feedback, what you'd like to see in our products. And thank you for taking the time to watch this video.
All
All right. Thank you very much, everyone. We're going to go into the Q&A. And so if you have any questions for any of the speakers, put them in the chat. I already collected a couple of these. And we're going to start with a question for Amy, which is, how are you planning to synthesize the sounds that will augment the consequential ones? And where will you place the loudspeakers?
Okay, so thanks for the question. I'll start with the second part first. So the speakers will be on the robots themselves. In some cases, we're intending to use, where possible, the inbuilt speakers that robots already have, or else otherwise a small, cheap, lightweight speaker, because part of the purpose is to be able to get any robot to make use of these augmentations. So in terms of what sorts of augmentations, we're looking at some masking techniques, but not to necessarily completely hide the noise, but rather to change the abruptness of it. So to have increases in intensity and decreases of intensity to smooth that out, to make people more comfortable around them. Looking at masking by using the robot's own consequential sounds that the robot has recorded itself, but also some generally perceived world sounds like Brownian and pink noise, or perhaps specifically tailored noises to be unique for that robot, so that you've got the more powerful sounds in there for the larger robots and the smaller sounds for the quieter residential type social robots.
All right, great, thank you. I have a question from John to Lucas. And the question is, could you listen to and understand everyone in a cocktail party?
Yeah, that's a really interesting question. And that's actually what the research I did in my master's thesis was on. So currently our design hasn't integrated that technology yet, but that'll definitely be one of the early things that we're going to be adding to the board, is the ability to spatially tune to a talker coming from a certain direction. So it would almost be like a steerable system where you could direct the system to, focus on a speaker coming from a certain spatial angle.
Great, thank you. I have a question for Omar, which is, how do you see your findings being integrated into commercial robots?
Okay, so this is actually an interesting question. So for example, it could happen for many things. So the audio localization model can be integrated in all types of robots. So in commercial robots, industrial robots, for example, this can be done through ROS, YARP. So, I mean, technically, this is possible. And also, theoretically, it could be easily happen. So I don't know where's the problem. Like, there will be no issue for integrating this on industrial environments, other robots for medical, social communications. Also, this can be done. So.
All right. Thank you. I see that Brian is answering a bunch of questions in the chat. So I just had a question to Pauline, which is, I mean, I already mentioned in the chat that I think this work is a great argument for manufacturers to think about the implication that their manufacturing decisions have on applications which can be very far down the line. in actual real world scenarios. So have you considered turning your work into recommendations for engineers to set up some sort of framework that ensures that these things are part of the discussion in the early stages?
Yeah, I think it would be very interesting to put from like this work recommendation for like creators or startups for robots, especially for kids with autism, because like it's a bit for that to really like think twice when they're choosing like motors, when they're choosing animations and everything. And yes, using motor sounds is like not a problem for some kids, but to really think about it and to design and to take it in account in the design.
Great, thank you very much. We have a comment directed at Lucas, which is, I think speech recognition is good, but inherently strips away a lot of important information. What effect bursts do we want to recognize?
Yeah, that's a really interesting point. I think it'd be cool to be able to sort of have something that can recognize sort of nonverbal affect sounds. But one thing I'm curious, does anyone know of good data sets for that? Because it would be interesting to maybe train a custom network that could do that. But yeah, that could be an interesting thing for the roundtable too, to talk about that for a bit.
Yes, for sure. I mean, I know we sent around some audio data sets, which I'm not familiar with, in the chat earlier. So if some of those are specifically for utterances, that would be really, really quite interesting. I'll monitor the chat for that. Okay, do we have any other questions for the speakers of this session?
I think we could take the question to Brian, perhaps to the plenary, sort of like, why did you choose these 4 conditions and were there any differences between them? I think those were the questions.
Yes, I might as well just also address Shrudi's question, which I'm typing on, but it's kind of similar, I think. So we talked to Dr. Dylan Moore actually when we were planning this study to start with, and you know, we were trying to test whether loudness or pitch were going to produce any differences and what direction that any differences were going to end up being. So that's sort of like the theoretical basis for the axis of our manipulations. And based on the advice from Dr. Moore, we essentially chose to just take really large steps to see, you know, if there's no difference at a huge step, we're probably not going to get a difference at a small step, right? So we took really large steps like attenuation by 10 decibels. I think the downshifting was by a full octave to see if there are going to be any differences starting from there. And then we followed that up with the 4 follow-up studies on the UR5E arm instead of the little black arm we showed you to see like how strong those were going to be at certain step sizes and stuff like that. So the follow-up studies were much more granular in terms of the range and how many or how big the difference was between each stimuli. Stuff. Yeah.
Excellent. Thank you very much. All right. If that's all the questions for now, we're going to move to the final discussion of the workshop. And we've kind of, we've collected a couple of more general themes and questions throughout the workshop now, and we're just kind of bring them up and see if anybody wants to speak to any of these. And we're going to start with the first thing that Guy Hoffman mentioned, which was the question about diegetic and non-diegetic sound in human-robot interaction. Guy, do you maybe want to frame that a little bit?
Yeah, let me just disconnected my camera. Now I want to make sure it's still there.
And also, Ben, if you would like to sort of, we welcome the keynote speakers to also sort of like be very much part of this discussion. If you want.
Yeah, so as I mentioned, I think the sort of like, I always really liked when you have in film and when artists play with this idea of what is diegetic and what is non-diegetic in the soundtrack, because it plays on our expectations. It also fits in with sort of like a more general notion that I have, that I think we should think about human-robot interaction as entertainment in some sense, and learn from other like techniques and traditions of entertainment to enable enable new and interesting types of interactions. And I thought this idea of diegetic and non-diegetic sound could be a good springboard for that, because it asks the question, like, what is real in the human world, what is real in the robots world, and how does it play with our assumptions of reality and of sort of conventions, and how do we use conventions to say something that is, you know, implied by the convention, etc. So these are some of the ideas I had on that topic.
Do we have anyone who wants to weigh in on that?
I could maybe jump in. I've done this before. I've done this experiment where I've given a bunch of maybe not roboticists the tools, the easy tools to make interaction. Actually, not even interaction. It's a show on the robot, and I say, here's your sound set, and go nuts. So they first put on this layer of stormy background, and it just sets this whole other dimension of what could be possible. It's not a assistant robot anymore, or like a helper robot. It's like we're walking, you know, now it takes you through this other dimension of, I don't know, you're outside and it tells you a story. And then, yeah, so I don't know if that's been explored as much as I think it could be, using sound first as like an anchoring to what that interaction is going to be.
Yeah.
We also have the potential with robots in that we could have the sounds that everyone hears and the sounds through augmented reality, so that we're having a personal communication with the robot. Because with bone conduction headphones and open ear designs, and even the AirMax Pros with listen through mics, and also the number of hearing aids that now got Bluetooth, we could have diegetic for the rest of the group, what everyone else is hearing with the robot, and then that personal communication between us and the robot.
Yeah, and I think that like orchestrating those different elements can be quite an interesting task, because if you can use sound to accompany what the robot does. You can use sound to be emitted by the robot, and then there's sound that the robot emits anyways. And you kind of try to find ways to orchestrate all of that in a way that it works in each individual context.
Yeah, so we could have this private channel of which we're experiencing the diegetic sounds of the robot, and then everyone else is experiencing the non-diegetic sound, as if it's a performance.
Like in those silent parties, everybody has a...
Yes.
It's an interesting performance piece where people have headphones and everybody hears the robot say different things, but they all see the same robot in the same space. And they have sort of parallel universe experiences of the same robot. Maybe interpret what's happening in personal ways.
I just checked. Silent Robot Disco is still available as a paper title, just so you know.
I think what we just discussed there fits also like something that we kind of like came up, I think, during Ben's question, sort of like, is the difference between how musical and unmusical people sort of like perceive that, and what would be the preferences for how like people would like their robot to sound?
Diegetic audio and just the thinking about what the robot's environment is and how they interpret it was actually a huge challenge for us. And part of building a character was to identify the limitations. So, you know, for example, if Cosmo's going to sing as a feature, we need to put something out so that we have a new component to the robot. But why would Cosmo know all of these songs? And as soon as you open the door to this implied understanding of the external world, it opens up the expectations that the robot's going to be able to do things that technically we can't do. So we put in a lot of self-imposed restrictions on what they could hear and how they could understand it. I thought it'd be really cool if, you know, if Vector could understand the difference between a doorbell, a dog, but it's just, it opens up an expectation. So we had to sort of manage expectations by not allowing that.
I just want to bring up a question that Bastian wrote in the chat, but Bastian, you can also unmute yourself and ask it directly.
Yeah, so it was like I had two questions. One was to Ben, whether you have any hints for the tools or approaches how you can use your research or like your product, what you came up with during Cosmo, to have like use it generally with other robots, and yeah.
That's a great question. So what we used on both Cosmo and Vector is there's an audio engine that's common in games. It's called Wise. I can share in the chat with it's 2 W's ISE. Very common interactive audio engine for games. And we were fortunate to use that with Cosmo and Vector. And actually, when building the audio system in Wise for Cosmo, one of the great things that Wise offers is a localization option. So that in games, for example, if you have dialogue with 1,000 lines of dialogue, you want to be able to translate that to other languages and localize. And so you can actually import the same file type, and then it just becomes a drop-down menu. And you can choose that entire interactive dialogue system works in different languages. You don't have to redo all that work. And so I imported all of Cosmo's vocal sounds as a language with the intention that down the road, maybe users would have the option to, you know, pull up another language, and it would be Cosmo with all the same animations. The audio is embedded where it needs to go. But again, the struggle that we had was making Cosmos so believable that, you know, having a toggle that we could just, you know, switch out all the sounds was just going to be too much work. So in terms of like a tool to experiment with that, I know this might be a long shot, but I know that Wise is free to use for under 200 sounds. So if you integrated this audio engine, you could, in theory, create a bunch of sounds for a voice or, you know, any sounds in general, and then have it localized. So you just switch and the robot would be the same thing. All the animations are the same, but it'd be an entirely new sound system.
So you would have to make Wise run within the robot system, basically.
That's right.
And do you see any any development that something like this is coming up, that more robot developers are using like a uniform system like that, or that yeah, basically it's about the robot manufacturers or libraries coming up, right? I'm not so much in this whole thing, so I'm wondering like what would be next steps to advance that.
I think that's an amazing question, and I would really like to know too. You know, working on Cosmo, I didn't know anybody else that was working on robots, and I'd never even considered robot sound a thing. And you know, I got to meet the sound designer that was hired on to work on Jibo, and we just got to, you know, joke that we're going to start our own little audio community that's away from games. And but there is some attention being drawn, especially by audio engines like Wise. So they've developed an API specifically for autonomous driving, so that the system in the car is communicative in the same way. So these emerging importance dependence on audio, I think they're still being developed, and them being valuable to audio system designers to create for them. But you know, it doesn't really answer the question. But I think the answer is I don't know enough people that are designing audio for robots to really advance this need. But I think it needs to start. Thank you.
Yeah, thank you. I think we can connect this perhaps with a like broader sort of like question that also came up, I think, during the chat, whether it's possible sort of like to use like the same sounds in the same robots, and how we could sort of like, yeah, how do we sort of like distinguish between different robot embodiments? I don't know, like if anybody would like to explore this further, answer any, share some thoughts on that. I guess especially as we've kind of come up already with the consequential sounds that kind of like play a big role in that as well.
wonder if anybody has sort of explored this idea of the maybe not inconsequential consequential sound, where robots have mechanical parts that all they do is just create different sounds, and it doesn't actually do anything. So it would sound like robot sounds, but it doesn't. It's not actually required by the robot to do anything else. So we'll just have like gears in it that will rev up to show excitement and things that click together. We had this actually with the head for the Shimon head. We had this eyelid, and it was made out of aluminum. And every time it blinked, it would make a cling sound, and people really you could really hear it blink, which was intentional because you can sort of, you don't even have to look at it, you can hear it sort of like do the blinking gesture.
Yeah, I remember reading about robotic artwork, which was kind of this blob of legs which is moving across the floor through an exhibition space. And the movement of the robot was put together using lots of relays, and those were clicking while the robot was moving. And so on the one hand, that was kind of the consequential sound of the robot, but on the other hand, it turned into this kind of alien, very idiosyncratic clicking communication noise. And then if the robot would move fast, you'd have a lot of clicking. So like there's some sort of interactivity in the clicking communication noises that works together with the movement. And then of course, people who would watch that robot would immediately think, well, it's trying to communicate to me. It's trying to run away or greeting me or something like that.
I think these like sort of like body sounds like also tie in nicely with like human sounds. We had this discussion about grunts earlier in the chat, sort of like, do humans make sounds when we move? And like guys sort of like suggested like we're so smooth we don't make sounds, but then actually like I think Ella also confirmed this, that there are like these train grunts that people make, and sometimes they can even be enhanced. Like there's some studies that when people do like weightlifting, that they, or like even I think some like fight sports was that like they can kind of enhance the strength. It's quite interesting like to see that these sounds are not only in robots but also in humans, I think.
Yeah, they had to ban them, female grunts at Wimbledon, because they were intimidating, but also the grunts gave the athletes who were making them extra power, because they were expelling as they were doing that. So there was considered an unfair advantage. But we do actually make a lot of sounds as we're moving. It's not our own bodies, it's the cloth that we're wearing on the surfaces that we're standing on or sitting on as we're going through, and we're very good at listening to them. So some of you will be old enough to remember when people started using mobile phones, and one of the jokes was that you always had to announce where you were every time you used a mobile phone. And now when people use mobile phones, you very rarely hear them discuss where they are, because we've become used to at listening for those auditory cues and what somebody's doing, whether they're paying full attention to you or they're typing on their keyboard. And they're or clicking the mouse or something like that, or shifting in the chair. And the Foley artists have obviously been doing this for decades. But we do have these sounds to interpret movements in creatures and in animals, whether dogs shifting in a bed or cats walking across walking behind us towards their keyboard. So it is entirely natural for us to want robots to make sound. Just as a case of it's too loud at the moment and to stop-start, as we've already heard. But because we've already got some warning of what the robot knows what it's about to do, we can start doing like Ben was doing, introducing those sounds so that it comes in much more naturally, and that we feel more comfortable with what it's doing. I think it's well doing, and it's well worth investigating, and not trying to make them silent, because it would be much more creepy for it to be silent than it to make sounds.
Yeah, I think we had a response to that directly from the chat. Dominica was asking whether it wouldn't be partially deceptive if robots would make human-like sounds. So I think that's also like a question. And I think we've seen sort of like how we can use voice sketches, and Ben has also talked about that, how human-inspired sounds can be transformed. Like with that, I don't know, like what does that do? How can we practically sort of like work with it? But also like, would it be kind of, yeah, unethical if a robot is sort of like pretending to play human sounds?
Yeah, I mean, maybe I hop in here. So I noted a question for Ben, which maybe connects here. I mean, so you, at the end of your talk, you talked about how children are reacting to your robot. And I was asking, how do you tell the children that the robot doesn't really has emotions?
I think the simple answer, and as a non-parent, maybe it's unfair to say, but my simple answer is that not to. I think it was great that they developed these relationships, and I mean, it was a blessing and a curse. It's great when it worked out well, but if I made an audio change with something that a child really identified with, it would ruin their experience, and I'd get some upset letters from parents because we changed something about the way the robot sounded, and the child would no longer recognize their friend. So I think in some cases, maybe breaking that fiction is important, but for the most part, allowing children to enjoy that companionship, I think is more important than bringing them back into the dismal reality we're in.
I mean, in a larger context, this should be something we should always be aware of. And this was exactly the point what I was talking about, about fake promises. I think it's really important to design these audible presence in a way that is somehow respectful to us. I mean, I think it's a quite important discussion, which I don't really see, but I think it's really important.
Yeah, another instance with Vector, the way people interpret sound is very different as well. So I think a lot of our successes, if I'm being honest, I didn't know that people were receiving the audio that way. So with Vector, and for example, I made a huge push for more what I thought was emotive clarity and improving all of the sounds across the whole robot. And that was the update that was going to happen. It was Friday. We were ready to push the update, and on Monday we found out the company was closing. So I never got to push that out there. And another company came along and acquired the assets, and they made the release of all of my work that I was so excited to share. And apparently I replaced one sound that everybody in the community identified as a laugh. And I don't know how to go out there and say, hey, I'm sorry, I never designed a laugh for Vector. He doesn't laugh. He doesn't do that. But the community was absolutely livid that Vector no longer laughs. And you really can't force people to understand what the character is, but they'll draw their own experience and conclusions themselves, and that's sort of special in itself.
Perhaps that ties in also with what we kind of discussed a bit in the beginning, sort of like people have different preferences and they also kind of like make their own meaning. Like I think, yeah, that's sort of like the context, like when we place a robot, like I did a study like with Cosmo in the home, and like you cannot sort of like determine from the beginning saying sort of like this is what it's going to mean, but people make their own meaning. Kind of, yeah, I think important to keep that in mind, that when working with like sound, we're kind of also working in a very ambiguous space, which is I think really great, but yeah, we can't sort of like determine from the beginning it's going to be this emotional, it's going to be sort of like exactly this this intent that we can communicate.
But Hannah, I was wondering, are there any design principles? So for example, the sound that a robot makes must match the appearance of a robot. So if the robot is big, you use a lower pitch.
That was our experience. Part of trying to discover the sound for Cosmo, and then of course Vector, that it needed to sound small, and some of the, you know, the voice stuff, especially with recording actors without pitching it up, it just sounds completely out of place. And it's one of those things that I think people inherently understand that it doesn't sound right. And we didn't get a whole lot of experience in it, but we did have a robot in development that was about maybe 3 or 4 feet tall, much larger, large wheels, very large screen. And by applying Cosmo sounds to it, just even to use as placeholder, it ruined the experience right away. So we had to sort of come up with bigger sounds that were more full frequency. But not only that, but you could have more interesting full frequency, bigger sounds. But we found that because it's like potentially a dangerous object that's moving, they need to be a little bit more polite. If you had sort of the reactionary, angry sounds that Cosmo had coming from like a, you know, 50-pound large, fast moving robot, that would be a hard experience in the home. So yes, form factor, size, very, very important considerations.
I just quickly want to follow up with a question here for you, Ben. So, I mean, it also popped up earlier in the chat. So you kind of got this body of experiences that you've now put together from creating sounds for these 2 robots. And to my knowledge, you or Anki haven't really like shared these in a formal way. And I was wondering, what do you think would be the best way to communicate these learnings? How would you teach somebody to recreate what you did there?
You know, that's another great question. And until, you know, I was contacted, you know, even understanding that a conference like this that exists was just so far outside of my understanding. You know, everybody I worked with was going to, you know, robotics conferences that are deeply technical. I didn't realize that there was an interest in this. So as it stands, I'm just happy to jump up and, you know, give presentations or email people or have conversations about it. Anybody who's interested in hearing it, but, you know, until recently, I didn't know anybody cared. So in terms of sharing this, you know, I still have the original projects. I have all of the audio, and it's just sort of collecting dust on a drive. But also the Anki assets were acquired by another company. So the intellectual property does not belong to me. So it's a little difficult, but I don't think there's any resistance or limitations to being able to speak to it. So I guess I would ask you, you know, where are good avenues to share this information with? This is
of course, that's, sorry.
I was just saying, this is a great example of getting that opportunity, but otherwise I don't know where to go.
Yes, I mean, for us is kind of, it's an interesting question. How do you put that knowledge in different formats? I mean, Kiet talked about design principles. Obviously, there are lots of quantitative studies, which kind of like give you clear numbers on what does what. And those are, of course, different approaches. So I think this is also still like something that's in development. How do we most effectively bring that knowledge in a format that people can take it and apply it and create robots that sound as good as Cosmo and Vector do right now?
Yeah, I suppose just staying active in this community in some capacity is the only thing I can think of. This is the only place I know where people are interested. And I mean, I feel, even with my limited experience in robotics, it seems like it's an absolute inevitability that this is going to happen. So somebody's going to bring the next robot along, and somebody's going to do, you know, better and better work, making them connect with people. And that's going to become increasingly important for people to feel comfortable around them. So yeah, I don't know. I think this conference in particular, and this group in particular, is probably, I would guess, a small collective of people that are really going to help advance this.
Great, thank you so much. If Hannah is all right with that, we're just going to move to the closing remarks.
I think there were more questions, actually. Sorry, I think we have a few more minutes left. I just want to make sure that all questions are asked. I have more on the list, just a few. I think we had some questions that were about sort of like the kind of how to make sound without being annoying. How can we manage the transitions between sort of like interacting with a robot and the moments where it's not in focus? Like also like how can we transition between beeps and speaking? Like, I don't know whether we want to discuss a bit more about that. It's fine if you all say we're tired, we're done. I just wanted to make sure that we raise these questions so that they don't get lost. Okay, I think we can perhaps move to the closing. We have a poll to like decide which platform we would like to use to connect. And I'm gonna launch it now. So the question is whether we would like a Facebook group, Slack, Discord, or a mailing list. So we can continue these discussions. And I think this is actually something really nice now with like everybody working at a distance. And this is kind of like how Frederick and I met in one of these sort of like groups. We were kind of like in a group on qualitative research methods. And I think it's kind of nice to have a space where you can ask your questions. And I think we have a lot of links already coming up in the chat that we will of course try to share on the website. We have some resources. Okay, last chance to vote. I will end the poll now. Okay, I think the answer is very clear. Like we will make a Slack channel and invite you all. If there's anybody who hasn't received an email from us about sort of like the Zoom link and so on, then please reach out to Frederick or me so that we can add you and you will receive the Slack link. I think with that, we would like to first thank our keynote speakers for joining us and sharing your views on sound. It was really, really nice to have you. Thank you so much. We would like to thank all of the, I need to give a proper applause.
Quiet clapping.
Yeah. We would like to thank all of those, all of you who have sort of sent in position papers and took the time to like record your videos. We hope that you like this format. We were trying to make this like most accommodating to all the different time zones and people perhaps being very tired. And finally, thank you all for joining and listening and being part of the discussions. I think this was really, really nice. And we will keep the Gather Town room open. You can move over there and mingle or like remain here a little bit and chat if you like. But yeah, I think this is all from us.
Great. Yes, a big thank you also from me. I'm super happy about this workshop and I'm very happy that we got so much interest for it. And it was really inspiring to see all these very different perspectives on like the only common thread being like the medium of sound. And I think that's a really exciting way to look at the whole topic. And I've learned a lot. So thank you very much. And we hope you have a nice morning, evening, or lunchtime.